Good morning, everyone. Welcome to the 17th Annual Rhode Island All-State IDeA Symposium. I am Sharon Rounds. I'm the Principal Investigator for Advanced Rhode Island CTR and Associate Dean for Translational Science at the Warren Alpert Medical School. I want to welcome everyone on behalf of all the IDeA programs. This symposium has been in the works for planning for about a year, actually. And it has been supported by all of the IDeA programs in the state, and we're very, very grateful both for your participation and also for financial support. So the reason why health effects of environmental change is the theme of this events today is because it's obvious to all of us that our environment is changing in many, many different ways. And not the least of which is climate change. But in addition to climate change, there have also been changes in air quality, water quality. Microplastics are an ubiquitous problem, especially here in the ocean state. And I would say that right here in Providence, one neighborhood now is being dramatically affected by noise and concrete dust, air pollution from the demolition of the Washington Bridge. We have no idea what the effects of these events just here in Providence over the next few months are going to have on the residents of Fox Point. It's also really important for us to acknowledge and understand the important work that's been done with modeling and epidemiological studies. And particularly, we know now that community engagement in all of this work is critically important. Today, we're going to be talking about a wide range of environmental changes. And we have a very distinguished slate of speakers and terrific events. But first, I would like to introduce my colleague, Ed Horrett, who is the program coordinator for Advanced Rhode Island CTR, who will be introducing one of our distinguished guests.
Good morning, everyone. As Sharon indicated, my name is Ed Horrett. I'm a professor of medical science here at Brown University, and I am privileged to serve as the program coordinator for the NIH award that has established and currently funds the entity that we call fondly Advanced Rhode Island Clinical Translational Research. It's my pleasure and honor to introduce our first speaker, Senator Jack Reed, who is well known to all of us, I'm sure, but just briefly to say that he has long been a champion of science and biomedical research in Rhode Island, recognizing that our scientific institutions are not only centers of knowledge and discovery, but also engines that drive economic growth and community well-being. His enthusiastic support of programs funded by the National Institute of General Medical Science, and specifically the IDeA program, is helping to establish Rhode Island as an emerging life science hub. In Rhode Island, the IDeA-funded programs such as the Clinical Translational Research, CTR, and based at URI, University of Rhode Island, the Rhode Island IDeA Network of Biomedical Research and Excellence, and many other centers of biomedical research are not only pushing the frontiers of science, but also driving economic growth. And in large part, we have Senator Reed to thank for a good part of that funding. The Senator's commitment to Rhode Island researchers is not only advancing our understanding of complex biomedical challenges, but also building a very resilient economy that can readily adapt to future changes. it's through the support of the national leaders like Senator Reed that Rhode Island is becoming a model of how science can transform our community. Please join me in welcoming Senator Reed.
Thank you, Doctor. Thank you very much. Good morning. I'm in what the military describes as a podium defilade. You can't see me, but I'm here.
Here you go.
Oh. You see, I'm really quite tall for my age. You think of everything. That's wonderful. That's great. Well, let me thank Dr. Horth for the very kind introduction, and Dr. Rounds, thank you for your great leadership. A special shout out to the Warren Alpert Medical School and Brown University for hosting today's series of valuable, in fact, critical discussions about the environment and what we can and must do about it. Let me also begin by saluting and recognizing my colleague, Sheldon Whitehouse. Sheldon, as you know, is a national, indeed international leader on climate change. He is someone who understands these issues and also is a relentless advocate for policies that make sense when it comes to the environment and to climate. You are in a very timely conversation today. Every time we turn around, we understand things are changing quite rapidly. I must confess, having grown up in Rhode Island, the idea that you could stroll in here in October 24th at about, 65 degrees is, no, 50 degrees was Valhalla when I was a boy here in October. And that's not the case. So we know there's a great change undergoing, and we have to deal with it. We are looking at the cumulative effects of 150 years of human activity, and it has both benefits and costs, and I think we're beginning to recognize the costs dramatically. And we have to increase our knowledge in this area. That is the one best way to deal with these emerging problems. And last year, for example, the University of Rhode Island published a study that estimated that the top 2 inches of Narragansett Bay now contain more than 1,000 tons of microplastics, tiny particles, broken down plastics. It's built up over just the last 10 or 20 years. And these microplastics have made their way into everything, including the food chain. They've been detected in all different types of species of marine animals, from plankton all the way up to commercial seafood and whales. They've also now been discovered in human beings. So that is an issue that we should be concerned about dramatically. And concern has to be quickly replaced by active investigation, active research, and proposal solutions to deal with this. We don't know quite yet what are the long-term health effects, but my bet is that they're not benign. That's just a bet. I'm not a scientist. We have to recognize that climate change is impacting us all in so many different ways. Just as the chairman of the Armed Services Committee, I'll point out that it has huge implications for national security in so many different ways. Literally, the world is changing around us physically. 20 years ago, the notion that you could operate in the Arctic Ocean was nonsense. Today, you can operate in the Arctic Ocean. So we're dealing with a profound issue that affects everything we do. And we're, of course, we're seeing more extreme weather, and we're seeing it in odd places. If you asked me to bet 2 or 3 years ago about a hurricane in Asheville, North Carolina, I'd say, you're crazy. Maybe Rhode Island, hope not, certainly Florida, but not Asheville. That's just another example. And we're seeing temperatures grow. The heat in New England, I mean, again, today is unusual for late October, but the summers have been in the 90s and close to 100. You know, when I was a kid growing up here, air conditioning is something that nobody had, but we all wanted. And now you have to have it just to get through the day. So we're in a situation where these environmental effects are becoming more and more profound, and your work more and more essential to what we do. And we're well positioned, as the doctor said, here in Rhode Island. A combination of great medical professionals, environmental professionals, biomedical professionals, great universities, hospital systems, researchers. We are ready to go, and what we really need is the resources to start the effort. And one of the many benefits of the Institutional Development Award, the IDeA Award, is that we are reaching out to areas of the country that and many times are bypassed by traditional NIH programs. So what we're doing is bringing in everyone, the brightest minds, regardless of where they might be located. And this is an extremely important program of NIH. NIH is one of our, of course, great, powerful forces to deal with these emerging problems. And IDEA funding has been a great boon to Rhode Island. It's boosted research. It's helping to train young and talented researchers, which is critical. We have to keep the pipeline full of dedicated, talented, innovative people, and we are. And that's why I've been a strong supporter of NIH over my entire career in the House and in the Senate of the United States. And I serve on the Appropriations Subcommittee that appropriates the money for NIH. And we were able to fund NIH in 2024 at over $48 billion, including an increased funding for the IDEA program, of nearly $431 million. In my mind, that's money well spent, because it's dealing with these issues that are emerging and becoming more and more critical to us. It also, as I pointed out, particularly the IDEA program, looks behind or around the usual sort of pipelines of funding into research and tries to find areas that have the talent but have not yet got the money. We want to match that talent and that money, and I think we're doing with the IDEA program. And please, I am going to continue to fight for NIH funding. I think if we do not continue to fund this type of research, then we are going to be victims of climate change. We're not going to be masters of climate change. So this is a very important session. Please keep up the good work. We'll try to keep the money going, but it's not money that's going to solve the problem. It's ideas, innovation, ingenuity, the talent that you bring to bear. Thank you very much for all you do. Thank you. I used to be tall.
Fantastic. We're very grateful for the support for all of our programs. Next, I'd like to introduce Dr. Bethany Jenkins. Dr. Jenkins is the Vice President for Research and Economic Development at the University of Rhode Island, and she's here to give a few welcoming remarks. Thank you, Beth.
Thanks so much, Sharon. It's always hard to follow Senator Reed and his insights. It's just we're so lucky in Rhode Island to have a congressional delegation that understands our planet is changing and that we have to look at the realities of that and structure our research to tackle these major global problems. As Sharon said, I'm at the University of Rhode Island, and in addition to serving URI as its Vice President for Research, I'm also an oceanographer and marine microbiologist. So the fact that we're here today to talk about the health effects of environmental change is a topic near and dear to my heart. And my own laboratory group studies harmful algal blooms that are responding to these environmental changes, and some of these blooms form potent neurotoxins that impact mammalian brain function. And so this is something my group has been looking at here in our backyard in Narragansett Bay as our temperatures have been rising. So I'm really excited to hear about the scientific aspects of this conversation this morning. And really today we're here in Rhode Island to celebrate the sustained success of all of our collaborations across our institutions in biomedical, clinical, and translational research. And it's nice to see the environmental research kind of coming into this ecosystem. I really want to recognize the platform and pipeline that the advanced CTR here at Brown University has built, really fostering a pipeline of talent across our institutions and providing this networked, innovative hub, this statewide hub for workforce training, research award programs, and events like this that bring us together. And really the impact that it's had on some of our earliest career scientists really needs to be recognized. So Sharon and Ed Harwood, I'm really grateful to you for leading this program and coordinating this with our partner institutions in the hospitals, Care New England, the VA Providence Healthcare System, URI, and Lifespan. We're really grateful. In addition, it was briefly mentioned that another aspect of this are these centers of biomedical research excellence, COBRAs, that are across the state of Rhode Island. They're a really important part of this network as well. And the Rhode Island IDeA network in biomedical excellence is homed at URI and has been present since 2001 and is currently led by Dr. Bongsup Cho at URI, that has many of our state partners. So that's also been a really important program for training, developing infrastructure and core facilities, and again, supporting some of our earliest career scientists. So I just want to recognize this pipeline. And another piece of this at URI, I think that can really come into this conversation is we have a National Institute of Environmental Health Sciences, which is NIH-funded, STEEP Center focused on PFAS, the forever chemicals that, in addition to microplastics, we're hearing more and more about. So those are in our food systems, drinking water, and so again, that this is a network of institutions in Rhode Island and in Massachusetts that are working in this area, and so that's another place that NIH funding has really supported work in this intersection between environmental and human health. So I want to conclude my remarks today with an absolutely shameless plug, Yes on 2. So this is really to celebrate the excellence in biomedical research across our state. And we have a bond measure coming up in our November election that's for biomedical research, and it's a general higher educational bond, which is 2. And it supports URI and RIC in improvements of our higher education facilities. But importantly at URI, and importantly for our excellence in neuroscience, it supports an $87.5 million life sciences building on the URI campus to house some of these amazing researchers. So I hope that you remember us at URI when you vote, and our colleagues at RIC in the upcoming election, because we're really excited to see a facility that supports our excellent research. So thank you so much.
Next, I would like to introduce Greg Hirth, who is the Interim Vice President for Research at Brown University and also, appropriately enough, Professor of Earth, Environmental, and Planetary Sciences. Greg.
Thanks a lot, Sharon, and welcome everybody. So 1 month into this new position I'm taking on, and it's really clear to me that symposia like this are great ways to advance new ideas in these areas. The collective organizations here working together, and it's such a great opportunity to take advantage of strengths across the state from the hospitals and universities. And the programs that Bethany outlined are really great ways to do that. So, as Sharon said, my career has been in earth and environmental sciences. And today I'm looking forward to taking part in the beginning of the symposium, but I'm actually leaving at 9:45 to go teach a class on an introduction to earth and environmental sciences. And that's a class that I actually TA'd back in 1988. And I want to give you some perspective on how much that class has changed in the convening time. In '88, there was no environment in the name of the department. It was geological sciences. And we talked about fascinating things about earthquakes and volcanoes and minerals. Today, the class has been transformed incredibly over the last decades. And many of the lectures actually include call-outs to the role of the environment on human health, which is pretty cool. So when I was invited to come down and say a few words, I put that in perspective. And one of the things that I was just reflecting on is one of the labs in the class is on the quality of drinking water in Rhode Island and the impacts that has on human health. So, let it be known that beyond the med schools and hospitals, there's so much science going on that's relevant to this in engineering, chemistry, earth sciences. And the thing that's great about the symposium, right, is that transdisciplinary research leads to translational ideas. So that's the IDeA Symposium is really cool for that context. So just a word about the Division of Research, just for everyone that might not be as familiar with it. There are two branches or two offices in the Division of Research that are particularly relevant for this. One is a research development office. And so people that have new ideas of how to bring together themes from a symposium like this, you should really reach out to our office. Adele Minogue is the director of that group. There's a lot of resources there to help bringing together new ideas and even consulting with funding agencies of how things might work. So I really encourage you to do that. And then the other area that is important to reach out to are the Brown technology innovations, where people are actively looking for partners to help translational ideas into industry and corporations in the Rhode Island region and nationally. So it's going to be a great symposium. Thank you for inviting me down, and I hope you guys have a great day. Thank you.
Next, we are pleased to be able to present in a video welcoming comments from Dr. Michelle McGruer, who is acting director of the Division for Research Capacity at the National Institute of General Medical Sciences. This program, Division for Capacity Building, funds all of the IDeA programs, and Michelle, I've gotten to know her quite well over the last few years, has been a wonderful advocate and supporter of all that we do here in Rhode Island. So she is not able to be here in person, and because she lives in, I think, Idaho or Montana, some different time zone, she requested that she be able to pre-record her comments. So are we ready to go?
We're ready to go.
Thank you so much for the invitation to speak with you today, and I hope you have a wonderful conference. I'll start by thanking Congress for its steady support of the IDeA program over the many years it's been in existence. And I want to thank you too for sharing with your representatives just how vital the program is to Rhode Island. The IDeA budget has continued to rise over the years, and Rhode Island has certainly benefited from that. In fact, you received over 6% of all of the IDeA budget awarded in fiscal year 2024. Overall, the IDeA budget makes up about 11.4% of all NIH funding that goes to Rhode Island. And just a few years ago, that was 13%. So Rhode Island has definitely made progress in parlaying IDeA funding into independent NIH support. Congratulations. In fact, Rhode Island is a bit of an overachiever when it comes to IDEA. It has a CTR that's deftly led by Sharon Rounds. Sharon was also a key member of the NISBRI organizing committee, which is our biennial meeting that we had in June of this year. And we all owe her a big round of applause for her hard work. Rhode Island has also 10 different COBRIs spread out among its research-intensive institutions and hospitals. And I have to just thank URI for its leadership in managing the statewide INBRI Award that supports primarily undergraduate institutions. So what more is available to help Rhode Island? Well, I strongly encourage Brown to submit a LEAD MSTP application. This T32 is designed to help create clinicians, scientists, MD, PhD students, and train them. It's restricted to IDEA states, HBCUs, and tribal colleges and universities, which helps level the playing field when it comes to getting through those pesky review panels. I would also encourage IDEA programs to submit applications that support diversity students and postdocs. This should be for a specific person who has not yet been supported on that award. The mentor should be at a more advanced level career-wise than the mentee. So that means that a COBRI research project or INBRI project should not propose a diversity supplement to support another faculty member, since that would be considered peer-to-peer mentor-mentee relationship. But that means that support for students at high school through graduate school and postdoc trainees is certainly eligible. Now, NIGMS is very committed to supporting resource-limited institutions that want to conduct research. And this is especially relevant to the PUIs, the primarily undergraduate institutions that are supported by INBRI. The SURE R16 program has been going on for about 4 years now, and it's a good success. So the R16 support faculty research with student involvement. But the SURE Resource Center can also provide seed grants of up to $50,000 for a year to help establish or enhance an office-sponsored program. Last year, also, NIGMS led in brand new initiatives to support instrumentation purchases at smaller schools. This is called the RLI-S10 program. Institutions can apply to buy an instrument costing up to $250,000, and that amount can even include maintenance contracts for up to 5 years. The equipment can be used for teaching too, not just research, and the user group does not need to have R01 level support. Now, change is inevitable, and here are some recent changes and some upcoming ones for the IDEA program. For COBRIs, the cap on the number of phase 1 and phase 2 COBRIs was increased from 3 to starting last year. Recently, NIGMS Director John Walsh just announced that he'd like to see COBRIs focus more on basic research. Currently, only about 30% of COBRIs are involved in basic sciences, and he'd like to see more come in that support basic research. For CTRs, we have recently funded the new CTR Development Award, and 4 of those have been awarded thus far. Monica Bertinoli's Care for Health program will be growing in the coming years, and there should be some opportunities for the Rhode Island CTR to participate at that time. That program involves engaging primary care providers at community clinics in research. And finally, our review branch asked us to help spread out and more evenly distribute INBRI renewal applications over the 5-year cycles. So some INBRIs are getting an extra year of funding to delay the start of their 5-year awards by a year, and that helps move them into a different fiscal year for the next reissue. Finally, there are some changes to personnel coming up. First, the unflappable and efficient Brian Iglesias is being reassigned to a different NIGMS program, and the Rhode Island portfolio of IDEA grants will be divided now among 2 grants management specialists. Both are very experienced, even though one will be new to IDEA. Mercedes Rubio has been selected to lead the Division for Research Capacity Building. Mercedes comes with lots of management experience in training and capacity building. I wish her the best, and I know the program is in good hands with her at the lead. Finally, I have accepted a new position and will start on November 17th. I want to thank you for being such terrific grantees and such a joy to work with, and I'll miss you all. And with that, I hope you enjoy your conference and have a wonderful day. Thank you.
We will miss her. Next, Ed will introduce the last of our opening remarks.
So it is my distinct pleasure to introduce recorded remarks again by our next speaker, a longtime supporter of science and innovation in Rhode Island, Senator Reed's partner in the Senate, Senator Sheldon Whitehouse. Again, as Bethany mentioned earlier just this morning, that Rhode Island is truly blessed to have such a strong and supportive congressional delegation. Senator Whitehouse, in his role as chairman of the Senate Budget Committee and the Caucus on International Narcotics Control, and a senior member of a number of other Senate committees, has consistently advocated for initiatives that support our local economy and the global future. During his previous role as Attorney General for Rhode Island, he helped found the Rhode Island Quality Institute, known as RI-CTR-N, an organization aimed at bringing stakeholders together to improve the quality and performance of healthcare and healthcare delivery in Rhode Island. Today, Rhode Island Quality Institute runs one of the most robust statewide health information exchanges in the country. And now, Senator Whitehouse.
Hi, this is Sheldon Whitehouse. Thank you so much for including me in Brown University's IDeA Symposium. I'm sorry I'm only participating electronically, but that's the way things are. I need to be in Washington. Thank you also for focusing on the problems of the related problems, I should say, of climate change and ocean plastics. Plastic pollution is now throughout the oceans, from the bottom of the Marianas Trench to the farthest away islands and shores. Even in our beloved Narragansett Bay, it's now estimated that there's 16 trillion pieces of microplastic, adding up to maybe 1,000 tons of plastic. And we have a lot of work left to do to figure out what that plastic means when we ingest it and it gets into our digestive system and into our brain and organs and so forth. So really important that all of that is going on. Obviously, climate affects our health in a whole lot of other ways as diseases move northward that we didn't usually associate with Rhode Island, as people suffer from heat. Brown University has done particularly good work identifying the extent to which heat is lethal to individuals. And of course, climate change is banging away at our economy as well. The door that it's banging on right now is the insurance industry, which has to look forward and see real risks and price accordingly. And I just got back from a visit to Florida because their whole property insurance system is in meltdown for that reason. So focusing on climate change is really important. I'm so glad you're doing it. Thank you to the work of all of the climate advocates at Brown University.
So with that, we can move on to our program, and we'll again have the honor of introducing our first keynote speaker, Dr. Kari Nadeau. Is John Rock Professor of Climate and Population and Chair of the Department of Environmental Health at Harvard's T.H. Chan School of Public Health. She will speak to us on climate change and health, innovative solutions to act on. Welcome.
It's a pleasure to be here today. I'm going to go right there. I'm really excited because I've been inspired and catalyzed by your wonderful senators, as well as many of you in the room. I have the pleasure of being from New England myself. And so when I had the opportunity to return here, I really thought about all the work you're doing here at Brown And 10 years ago, I worked with Senator Whitehouse for looking at the causal relationships about climate change and health. And so to return here and to be able to look at where we've gone is really important. I wanted to focus on solutions today because I think as we work together across New England, across the country, across the globe, we really need to reconceive the problem and co-create the solutions together and then test those solutions. And I also want to highlight the fact that in the magazine, right outside this wonderful classroom in Brown Health Discoveries, there's a great article on climate change. So I hope you all will read it. On my way down from Boston this morning, I had the pleasure, of course, of seeing all the beautiful colors of the trees, and really I'm always excited about being in New England in the fall. But then, of course, the temperature, which Senator Reid also mentioned, is somewhat unnerving. And so I think we need to think about that in our daily lives. What's going on, and how can we be part of that solution around us as we think about these changes that are occurring on a daily basis? And when we look at what's going on across the centuries and millions of years and billions of years of our planet, we are truly in the Anthropocene era. We are using fossil fuels beyond reach, and because of that, we have increased greenhouse gases. You can see the steady uprise as well as steep increase in fossil fuel use across the years here on the x-axis, and unfortunately they are contributing to many greenhouse gases, not just fossil fuels though. We also have methane, we also have other fumigants that are in the atmosphere that are increasing greenhouse gases and staying longer than we thought in the atmosphere. And with that, that's leading to increased temperatures. If anyone's interested, you can go online and look in your local area as to one of these quote unquote heat temperature monitors, and they're called our heat stripes. But over time, it's not just New England that we're seeing increased heat waves. And a heat wave is defined as 3 days of over 90 degrees Fahrenheit. And that's seen as dangerous to health, but even degrees that are less than that if you're exercising are dangerous to our health. So these types of heat stripes are really helpful for us to look at over time, as well as to look at on our specific areas where we live. What's happening is that with this global climate change and with increase in temperatures and the changes over time in both healthcare issues as well as loss and damage due to hurricanes and extreme weather conditions, these are costly. The loss and damage is basically adding up to trillions of dollars over the last 10 years even. And this is serving as a catalyst for our wonderful legislative bodies in the federal government and our state governments. But this is something that we have to be able to deal with in an immediate way to be able to think about solutions. And so with that, I'd like to frame solutions within the perspective of how climate change affects human health. And this is a nice figure from the World Health Organization that was given to me by my colleagues. And importantly is that you're seeing that for any one given change that's associated with climate change in terms of flooding, rising temperatures, extreme weather conditions, increasing greenhouse gases, rising sea levels. Here we are in the ocean state, and you're seeing this as well with flooding and sea levels and algal blooms, as Dr. Jenkins mentioned. But importantly, as we think about categorically as scientists, as we break down different issues associated with different parts of healthcare, any one person can be suffering from more than one of these health issues at any one given time. And the other problem is that any child now born on our planet will suffer through at least one extreme weather condition associated with climate change. So there will be a compounding effect of the longitudinal nature of climate change exposure and health issues with that given individual on this planet, not only children, but also older individuals as well. And so I want to focus on these specific issues around climate change today. Unfortunately, fossil fuel-driven pollution, as well as increasing sand and dust storms, worsening wildfires, over-flooding, temperature increases, and changing patterns in infectious diseases. I was looking before I came here today as to what amount of heat waves you've seen here in Providence, and you've had long heat waves here. Unfortunately, since 2006, they've increased. Your heat waves have now doubled over time since 2006. You've had one heat wave, I don't know if those of you who remember it, that lasted 7 days of 90-degree weather patterns and over. And I think your highest temperature was 106, which, like Senator Reid said, it was unbeknownst to people that grew up here. So with that in mind, we need to think about increased temperatures, increased flooding, unfortunately. How many of you smelled and saw the red skies 2 years ago after the Canadian wildfires? So those were hundreds of miles away. And people in Washington, D.C. were also cloaked with wildfire smoke. And that catalyzed them to understand that this is real. This is not just occurring on the western part of our country, but also it can occur locally, unfortunately, because of smoke and how it can literally circumnavigate the world. And with that, I want to ground ourselves in the fact that we are a species that needs to live in a coordinate fashion with this planet. And our health is inextricably connected to the health of our planet. And with that, we have these concepts of planetary health, One Health. And I want to make sure that we drive that today. As part of our solutions, we need to think about biodiversity. We need to think about how to rewild the planet to be able to improve planetary health as well as our own health. And these two, again, are linked. And I've been working with the WHO at making sure that we educate people when we talk about solutions about how connected these are and how there are always unintended consequences in a negative way about deleterious issues around exposures, but there always are other beneficial potential unintended consequences of working together with the planet to be able to think about solutions. We are in a medical school, so I want to make sure that we can focus on health issues around climate change. There was a great article in the New England Journal written by my colleagues Karen Solomon and Regina LaRocque, in which they talk about climate change as a health emergency, not just for individuals, but also for public health and then for the healthcare system. And when we think about this, we need to make sure that no one is left behind. And that in a lot of the issues around climate change, what I believe is happening is climate change has really been the X-ray into the soul of health inequities and healthcare issues in general. And all of these issues were happening already, and those that were already inequitably exposed to environmental exposures. But we see that in a more deepened sense and a more broadened sense when we look about populations that are targeted by climate change. And so there are many at-risk groups that we'll talk about in a minute, but those that already have comorbid conditions, those that are older adults, children because of chronic exposures and their increased metabolism, and then underserved communities that are already in areas in the country or already in places like near highways or near toxic waste dumps that are already inequitably exposed. And importantly is climate change anxiety. This is occurring more frequently in all of us. I'm sure we've had anxiety when we read the newspapers, when we think about solutions that can help us face forward on hope, but we also need to be realistic about that and work with organizations and cooperate and collaborate to be able to think about these solutions. But these issues and the anxiety happen not just for us, but also across different populations in the US. And you can see there that a lot of people that are in underrepresented minorities, for example, are having higher anxiety than other populations. And with that, across the globe, all humans are being affected by climate change. This has really been a wake-up call, both directly and indirectly. Nutrition is being affected, plants are being affected, animals are being affected, and vulnerable populations need to really be looked at to make sure no one is left behind, as I was saying. And many different organ systems are affected by climate change. Let's focus on children before moving into adults. Air pollution affects 2 billion children on our planet. 80% of the world's children live at WHO standards above the threshold for pollution. With that, we also have seen increased cyclones, heat waves, riverine flooding and coastal flooding, and then water scarcity and vector-borne diseases. For those of you that have a tick-borne disease, for those of you who have grown up in areas of New England where you really have to be careful about tick bites, these ticks are spreading throughout the country as well as the world, and children are also suffering from diseases where they otherwise are in areas they wouldn't have had to worry about that before. Moving on to adults. adults and children are both affected globally. And this is a great paper that was published recently in 2022 by the Climate Impact Lab to show that if we don't revert to what we had agreed on in the Paris Agreement and try to go to net zero by 2050, what we're looking at is equivalent mortality rates that equal and are similar to the number of deaths overall in the globe caused by infectious diseases. That's a high number in and of itself. And so with this in mind, not only is climate change, of course, worsening already diseases and inducing diseases that otherwise weren't here before, but also it leads to death. And these are the numbers that we could be looking at if we don't stem the tide of climate change and reduce greenhouse gases now. So I want to move forward in my lecture about climate events and how they affect specific health issues. Now, any of these climate events could be associated with many different health issues, but I want to give you some examples, and I'm happy to talk about the biological mechanisms that are associated with these specific associations between heat waves and mental health, for example. Mental health is becoming more and more of an issue, not only because of climate anxiety, but also because heat and heat stress and the issues around how heat affects the biology of our bodies, how it increases heat shock proteins, how it denatures proteins, increases inflammation, that affects the brain. And heat alone physiologically affects the brain and the transmission of signals in neurons. So because of that, we have both short-term and long-term effects. As Senator Reid said, he's worried about the long-term effects of climate change. So am I. And I think mental health is one of those areas we really need to make sure we have our finger on that pulse as we think about communities that are affected adversely by climate change. So as we think about preparing and making sure that people understand that heat waves are not good for their bodies, especially the elderly, especially children, this is a great handout that the CDC put out. California has this put out. When I was a clinician in California, we gave this to a lot of people. The American Psychological Association has now shown data on their website, and I'm happy to talk about this more. But unfortunately, suicide rates increase, domestic violence increases when there's increased temperatures. And this is something that we know biologically to be true, but unfortunately now we need to make sure from a social science point of view, from a behavioral science point of view, that we can have anticipatory guidance for our families and for our patients to understand what they can do and how to prevent heat-related illnesses. So I want to move forward with air pollution. Like I was saying, air pollution is increasing and unfortunately leading to millions of deaths, about 8 million deaths per year, mostly in low to middle income countries in the global south. And importantly, though, in our own country, in the US, we've seen air pollution associated deaths, and this is a global threat to all of us. Air pollution is one of many features. Our EPA luckily regulates air pollution here in our country because we have been monitoring it for a very long time. But unfortunately, in other countries, they don't necessarily monitor it. In our own country, we didn't consider wildfires as air pollution until recently. And so with that, and because I lived in California for many years and I had to evacuate my own home 3 times during wildfires, I decided to reframe my research on wildfires and air pollution, but I also wanted to understand climate change and how it was associated with wildfires. So unfortunately, that data that is not just my own research, but also the research of many and teams throughout the world, 50% of our wildfires now across the world are due to climate change events. If anyone is interested, there's actually a great website called Carbon Brief, where you can actually go on and look at the climate scientists' attribution of certain extreme weather conditions and events to climate change. And that's where I was able to obtain this data, as well as many other people are studying this. And unfortunately, it's because of this vicious circle biologically of temperatures rising, increasing the temperature of the forest, as well as decreasing snowmelt. So your own wonderful university across your university is doing great things in climate change. So I also want to give a shout out to the leaders and I'm sure there are many others. These are what these names we were able to find on the website. And thanks for Sharon for leading the way here with our IDeA Symposium. But I would love to be able to think more collaboratively across our states, across our institutions, to work together on climate change, because many of the people at Brown, as well as URI, are working in climate change. So with wildfires, unfortunately, they're not so wild anymore. 50% of the fires that are going across the world now that we consider wildland fires also include commercial buildings as well as residential buildings. So you can imagine your shampoos are going up in the air, your paint thinners are going up in the air, the microplastics are going up in the air. We're finding them in the lungs of especially firefighters. And unfortunately, those are toxins that are about 10 times more toxic than pollution. And that's a sad thing to say. And unfortunately, a lot of those molecules get right into the bloodstream. And so with that, we need to think about the biology and the mechanisms of how those toxins activate the immune system, unfortunately affect the endothelium and affect the heart and damage the tissues of the brain as well. And unfortunately, we're seeing increased cancers. There's a publication that came out in 2022 in Canada from populations that were living near wildfire smoke in lay public neighborhoods, and they saw increases in brain cancer and thyroid cancer and lung cancer. We now know that there's a lot of issues with pregnant women. They have increased premature births as well as increased stillbirths when they have been exposed to more than 5 days of wildfire smoke. So we also have data now, because in California we have seen a lot of wildfire smoke and exposures. There's been a lot of epidemiology on this, and there's a lot of mechanisms now with different toxins in wildfire, especially heavy metals, and how that affects the immune system and our bodies. But what I want to really show you is that people that are in low socioeconomic status have a much higher rate of having some of the ill effects of these climate change issues, especially in wildfire smoke. There's a 12% increase in stroke, 40% increase in asthma rates for children less than 5 years of age, and then about a 50% increase in cardiovascular events within 4 days of exposure to wildfire smoke, even if the wildfire itself is hundreds of miles away. That's for any air quality index that's greater than about 200. So when we look about vulnerable populations, we need to think about farm workers as well and field workers. We're seeing the effects of a multiplicative effect, especially in farm workers where they're outside, they're exposed to the heat, they're exposed to air pollution, they're exposed to toxins perhaps in the water or pesticides, and then in addition, they're working and that heat stress affects their hydration status. So we're seeing specific diseases like kidney disease in farm workers across the US. And so the nephrologists that I've been speaking to when I go around to different medical schools have really been wondering about why this is. And this is a great example, unfortunately, of a chronic health condition that is being amplified because of climate change events and mixed exposures in any one individual, especially farm workers. And different ethnicities have a higher rate of these kidney diseases, perhaps due to some genetic differences in their GFR and how they process water and hydrate. But I wanted to specifically give you this paper from Lancet Planetary Health looking at the effects of climate change, heat stress, and other exposures in kidney disease alone. I think the mechanisms of this still need to be looked at. So this is still being looked at the epidemiological level, but I'm hoping more and more people really move forward with understanding the mechanism. So there's another unfortunate example of mixed exposures that is increasing more and more across our world and across our country, and that's the concept of thunderstorm asthma. And just bear with me as I explain some of the weather conditions. I am not a meteorologist. I didn't train in this, but what's happening is that as thunderstorms increase, as extreme weather conditions increase, as lightning storms increase and large clouds exist, there's more electrostatic conduction, both negative and positive charges within any given cloud. And what happens is that the pollens are emitted from the ground. They then get popped open by this electrostatic charge. And with the water being moist, they even pop open more because it's like wild rice being boiled and just opened up. And so that emits more pollens. And unfortunately, that can occur very abruptly in any one given hour of the day during these thunderstorm asthma episodes. And they are great examples of, unfortunately, perfect storm conditions with extreme weather events with climate change. And so, unfortunately, if our healthcare system is not ready, and this is just one example of resiliency building and capacity building within our healthcare systems, not let alone heat stress and flooding. But this event, for example, in Australia, led to a huge increase in admissions in the ER just within hours over days. And because the hospital wasn't prepared, this led to, unfortunately, deaths in their critical care unit because they could not deal with the effect of the status asthmaticus patients that were coming in and the numbers that were coming in over any given period. So if you remember back to your high school and elementary school classroom, CO2 is not great for our bodies. It increases temperatures on the planet. But plants tend to like it because they use it to grow and they use it for photosynthesis. But unfortunately, there's just a specific level that is good to grow as a plant. But if you go over that, it's actually toxic. But certain plants like CO2 better, and especially those plants that can cause allergies. So that's unfortunate for us, and that's unfortunate for me as an allergist and immunologist. But what you're seeing here is we're at about 420 parts per million now in the atmosphere. If we don't curb the tide of use of fossil fuels and greenhouse gas emissions, we're looking at the trajectory of about 720 parts per million CO2 by 2075. And so people have modeled this out. You can see here in Europe, for example, there's areas in Europe that would have the capacity to grow ragweed where there were no capacity before because of the cold effects, like, for example, in the southern part of Denmark. But unfortunately, each pollen, because that CO2 actually affects the acidity around the plant, that affects the covalent bond of the pollen to the plant. And so it actually increases the pollen being emitted from the plant. So not only do you have larger swaths of the earth being populated by these pollen-producing plants like ragweed, and not only is it expanding, but also per unit plant, you have increased pollen. And unfortunately, it also increases the allergenicity of the pollen because the acid in the air alone denatures the protein and allows it to be more antigenic to the immune system. So while I was practicing as a physician, my patients were coming in, and despite the aisles and aisles of many pharmaceutical, CVS, Walgreens, Rite Aid, having more and more antihistamines, more and more nasal sprays, my patients were saying, we're not getting any help. Our allergies are getting worse and worse every year. And yet we have biologics, we have better therapies to treat these diseases, but yet they're getting worse. So I decided to ask a postdoc in my lab to look at pollen counts over time over the last couple years, 20 years exactly, in the Bay Area. And we had one allergist who was getting the same amount and the same use of the same collection procedure on his roof for 20 years, so that we were able to then track this over time using the same exact method. And what we found was, unfortunately, within 20-year time, we had 8 to 9 weeks more of mold and grass pollens being emitted because of climate change. So it's not just about pollens and inducing disease, it's also about flooding. And Dr. Jenkins talked about the algal blooms here. We're studying this importantly as it relates to health. These are issues that with flooding, with sea level rise, as Rhode Island deals with this as well. You can see Rhode Island, the ocean state, there on the map as we think about sea level rise. These flooding issues are increasing. We just recently saw, obviously, in Florida being hit by 2 hurricanes back to back. We need to think more about how these flooding issues affect both acute and chronic issues. Infectious disease will be the last thing I'll talk about before we talk about solutions. But as you look at these maps, here we are in New England, where we thought Lyme disease was isolated to our region of the country. That's not true anymore. These diseases are spreading. There's a new disease also, alpha-gal, spread by the Lone Star tick, that we need to think about, that's also spreading because the tick can survive in warmer temperatures across the world. But our colleagues in Africa are also dealing with dengue and malaria, and dengue now has been seen in the US. So I'll pause. I do not just want to be a Debbie Downer today. I want to make sure that we can focus on solutions. And so there's a reason to have a balanced view. I'm very careful that we need hope and promise, but we can't be overly optimistic and we can't be overly pessimistic. So I like to make sure that we have this balance because we can be the change. And I believe that having that realistic notion can help us drive towards creating solutions together, like I said in the beginning of my talk. We're not at that net zero point yet. There's a lot of reasons to be positive. The youth movement, the most popular AP class in America is environmental science. Hooray. So build it, they will come. We're excited about this, but importantly, we need to make sure that all of us, all ages, contribute to part of these solutions and the science. There's a lot of work being done at the Conference of the Parties, the COP, but we're at the 30th COP next year. That's 30 years of trying to deal with this. We need solutions now. We have the technology, we have the monies. We need to now focus on behavioral changes to help us get to net zero. There are a lot of negative issues too. We need infrastructure. We need to think about the electronic grid. We need to think about helping those that have been otherwise left behind and other solutions. So in focusing on science and solutions, I think we need to make sure that we have solutions-facing research with policy-oriented outcomes. And with that mindset, in looking at these solutions, going from gene to globe will be really important. Understanding mechanisms, looking at solutions-facing research from large data where we're monitoring glacial melt-off, where we're monitoring places around the world that are at a health risk for flooding, where we're monitoring wildfires, but also down to the gene level, where we're monitoring a concept called exposomics. Any one of us has good and bad exposures in any one day over anyone's lifetime. And we need to understand as scientists how to drive that molecular level so that we can understand biomarkers as we think about solutions and track those biomarkers over time. So my colleagues, and again, I'd love to be able to collaborate more with Brown and URI on some of our programs. We have some monitoring that we're looking at now as to how it affects health and how we can have anticipatory guidance and monitoring for people using cell phones. I was just in Hawaii recently to make sure that the Hawaiian citizens have access to knowing whether or not there'll be a wildfire in their neighborhood that otherwise was not available to them before last week. Importantly is to think about ways to adapt to these issues around climate change, cooling sidewalks, making sure we have low-cost ways to adapt and mitigate climate change. And when we think about as scientists how we're going to look at solutions-facing research with policy-oriented outcomes, I think we need to measure, monitor, and track. And when we do that, we can manage better by understanding whether or not something worked or it didn't work and why or why not. So in looking at solutions, adaptation and mitigation are different from each other, but we need to think about solutions in a parallel track scenario. We have a program project grant from the NHLBI, and it's so great to know that NIH is funding the IDeA Symposium, as well as NIH has been critical to so many of the solutions that I'll talk about today. And I'm grateful for your senators in Rhode Island for really being strong points in Congress for helping us get NIH funding across the US and the world. So we're looking at solutions-facing research with policy-oriented outcomes and going right down to the mechanistic level of solutions. We are focusing on a part of the Central Valley in California that is exposed to pollution and wildfire smoke. Unfortunately, this is a group of individuals. It's about 1/3 of them have no jobs. Most of the community is below the poverty line. California, unfortunately, has the top 10 cities in the country for air pollution, and this is one of them. You can see here we gave smartphones to all the neighborhoods, and we also gave it to the children, and that's how we were able to, with their consent. And so we were able to actually track the levels of polycyclic aromatic hydrocarbons as well as other air pollution exposures to these specific families. So each diameter shows you how much pollution someone's exposed to. But you can see the major highways running through the Central Valley. They're also near agriculture. So there's a lot of mixed exposures. And so that's why we develop with a lot of people this concept of the exposome, understanding both healthy and unhealthy behaviors, but also exposures and how that affects individuals. So we're excited about testing solutions though, because like I said, we know climate change is bad for health. Now we need to focus on solutions. And so when you look at this picture, this is a way to think about solutions in terms of, again, planetary health. And I want to really bring back the notion of traditional ecology. I have learned so much from indigenous populations, and this is one example. This is from Oregon. This is a drone. In the top panel, you can see no treatment of a forest, where the forest management didn't treat this either. The wildfire ripped through this area in the top portion of this picture at 1 football field a second. People cannot escape. That's why we had people in paradise die. I don't know if you remember the front cover of Time magazine a couple of years ago. In the middle is the Native American reservation in Oregon. For thousands of years, they've been caring for that forest, cutting down every other tree and making sure that the fuel of the forest in the undergrowth and the old pine needles are burnt in small portions to be able to take care of that fuel. In the lower part is the forest that was taken care of by the Forest Service. Every other tree was cut down. And so that picture, I think, is truly worth 1,000 words. And unfortunately, a lot of parts of the West, and we haven't been able to convince Canada yet, but we're working on this, has restricted days for prescribed burns or beneficial fire, as you saw from traditional ecological practices from the Native American reservation. And so Indigenous peoples now have come together to train us and train our Forest Service how to use beneficial fire. But we had to also provide policymakers some data to show that beneficial fires are not deleterious to our immune system or to our health. And so luckily we had been studying the Central Valley, and we had populations that had gotten exposed to beneficial fire from Yosemite National Park versus wildfires from Yosemite. And luckily we had tracked them over time so we could compare them over time. And so, with that, and again, it's a small study because it's hard to do, but importantly, we were able to show that there was less air pollution, and we took their blood, and we were able to show that based on a T cell, which again is an inference for whether or not they can actually fight infections, because this cell is important, the Th1 cell, to fight infections, we were able to show that those people that were exposed to beneficial fire or prescribed burns had about the level of Th1 cells as the control, which didn't get exposed to any wildfire smoke compared to those exposed to wildfire. And again, this is just small amounts of data. I hope that those of you who are interested can look at this data again and test it in other populations. But this led to changing the Biden-Harris administration Wildfire Commission with myself and traditional ecologists and indigenous peoples were able to come together with data to show that there should be more prescribed burn days around our country and make sure that they had resources to stop the prescribed burns so that they are controlled. So that allowed Congress to be able to pass and get more money. So again, we want to focus on policy-oriented outcomes through solutions that are science-based. This is another example. Many of you raised your hands when I asked about getting and seeing the air with the wildfire smoke from Canada last summer. But you probably were asking, should I be wearing a mask? What kind of mask? Or other people were asking you if you're physicians or healthcare providers. There's not many studies on this. So this little girl is out in the middle of COVID. She's wearing a surgical mask, but that's not protecting her from this wildfire smoke, which occurred at the same time. And so what I tell my patients is increase your time indoors as long as the indoors is safe and has reduced air pollution exposure. Use an air filter at home, as well as use the right mask. Well, how do you know what mask to use? Well, luckily there's 1 or 2 studies now showing that an N95 mask is the one that actually reduces air pollution exposure, but not the gases, not the volatile organic compounds. So we need to be careful, and ultrafine particles too are not reduced by N95 masks, but it's better than nothing. Many of my patients ask me about air filters. And so there are now studies to say that air filters work. They reduce air pollution inside your home. You need to really use them effectively and monitor them, but you need to use the right amount of air filters for the right surface area. There's a lot of physics in this slide, basically, to explain that you need about 3 air filters in any one given home to be able to reduce air pollution exposures. And so we were able to show this data and able to show that it reduced air pollution in a meta-analysis that was done and published. And so we took this data to the governor's office in California because many people were dealing with wildfire smoke. And we, as physicians, a group of physicians, a small group, there were only 5 of us, went to the governor's office. And at first they said no, but we went back the next year. And we knocked on the door again, and we said, we need an air filter prescription that then gives low to middle income communities and families free air filters for their homes. And that's what we did. And so now we have an air filter program for the state of California that gives air filters for free to low to middle income families. And we're trying to now move that forward in Massachusetts too. So if you'd like to join me, please let me know if Rhode Island might be interested. We also were able to show this data, which again is a compilation of meta-analysis, but many people ask, well, sure, air filters reduce pollution, but did you actually improve lung physiology and lung health? And yes, you do. So at least for this data here, you can see FEV1 is improved, and we're able to also take this data to the governor's office and then establish, especially for farm workers, clean air rooms. Now, clean air rooms can't be established throughout the country, so they're not the solution for everything, but at least for people working outdoors, we now can have clean air rooms right next door to where they're working so that it reduces their exposures. So I promised I'd talk about nature-based solutions. We touched upon that a little bit with the traditional ecological practices in wildfire management, but I want to really talk about this great data set, and I hope if you take home one message, it's this, that if you plant trees in a city and you increase tree canopy by 30%, you reduce your temperatures in the inner city by 1.3 degrees. And with that, you reduce premature deaths by 30%. 30% increased tree canopy, 30% reduction in premature deaths. And this was done by our colleague at Yale and across many cities in Europe. But this gives you, and I hope today you'll multiply these messages of solutions, that these are possible and very tangible. When people argue that solutions now you'll have to wait to actually see the benefits, that is not true. People saw the benefits within days of making sure that the tree canopy was increased in cities. As an allergist, people say, well, if you biodiversify, if we rewild the planet, aren't you going to increase allergies across that city or across that area? Actually, the data says otherwise, as long as you plant mixed sexes of trees. In San Antonio, for example, they planted trees, but they're all male. So they're constantly searching for the females and putting out their pollens miles and miles away, and pollens will travel miles. And so they need that feedback loop. And again, I'm not an ecologist, I'm not a botanist, but I have had to look into this to be able to answer some town council questions. So if and when that becomes a question here in Providence, please say that no, allergies actually are decreased if you plant the right trees, and you plant the right trees next to each other. So again, in co-creating solutions with community, Sharon talked about, as well as others, the importance of the fact that many of these solutions need to be hyper-local and need to be community-driven, and we need to have community engagement. So when we talk to communities, we ask them, what is the most pressing issue? We don't necessarily use the word climate change. We use the word heat stress or flooding or algal bloom. And so for the community in Fresno, we said to the families, what's the most pressing issue? It was air pollution. How can we make sure that air pollution is reduced in our children? So we went to the local high school, asked them to put a policy statement together. We knocked on the door of the town council to reduce the diesel emissions for buses that they were using to get to schools. And at first the town council said, no way. We went back again a no. Within 4 years, we were able to convince them to switch to electronic vehicles. And that was because we used data from LA. LA, as many of you might remember, had terrible pollution back in the 80s. And now today, they've used regulations to reduce that. But again, scientists examined the data. They examined the physiology of the lungs that were being affected in the children that were close to highways. And they were able to actually show over 4 years, by reducing diesel exhaust, by reducing highway emissions, the lungs of the children actually grew much larger than in the past. And so that was great to see, and great to be able to take to Fresno and say, here's why we need to change from diesel buses to electric buses alone, just to be able to help children's lungs. But many policymakers say, well, electric vehicles are expensive. What's the bottom line? I want to know what the benefit cost analysis is. So for those of you in the audience that have economics degrees, and again, I do not. But importantly, you can take health benefits and be able to then look at equations to be able to think about the cost benefits that you get out of the health benefits as well as climate benefits. So my postdoc, one of the postdocs at the Harvard School of Public Health actually looked at this data, and we were surprised. We thought that there would be a net zero because electric vehicles can be, when you pay for them, expensive. Now, the EPA instituted inducements to be able to give free electronic vehicles to switch out from diesel. So we looked at neighborhoods that had done that across the country, and we were able to show that there's a net positive savings of $270K for every bus changed from diesel to electric. And that's even more so for those buses that were older and switched out in the inner city. This is just based on mortality risk. This is a very conservative number. So I'm hoping, again, for those of you interested, that more people do this science and be able to take it to policymakers and show them that actually within 28 days, we were able to show improvement in health from individuals riding an electronic bus. My colleagues at Columbia, as well as Boston University, also showed that for every dollar spent in reducing greenhouse gases, and this is in New England, so I thought you'd be interested in this, you get $6 out in co-benefits. You reduce asthma admissions, reduce medications, and this is just for children. So again, if you take some messages home, 30% increased trees, 30% reduction in premature deaths, $1 in, $6 out for reducing greenhouse gas emissions. This is just in New England. If you could imagine if you were in China, the number would be much bigger in terms of benefits. So I want to take a step back and think about our own institutions. We are in the healthcare system. Unfortunately, we need to get our own house in order. We contribute to about 9% of all greenhouse gases. I'm including myself, working in the healthcare industry, we contribute to 9% of all greenhouse gases in the US. So we need to think about being better citizens, being better role models. Our role model now is the National Health Services in Britain and in the UK, because they have gone to net zero. That means their supply chain had to go to net zero. 30,000 companies now have made green, ecologically friendly materials to be able to bring to the National Health Services across the UK. So what I'm saying is we're ready. So I don't know if the state of Rhode Island signed on. I know the US signed on in general to the COP policy to be able to take our healthcare system to net zero. Not only should we reduce our greenhouse gas emissions, but we can practice better in terms of reducing pollution. So in being our own better role model, I've just put some examples there. We talked about microplastics, you heard from Senator Whitehouse and Senator Reid. And importantly, microplastics will be affected by climate change as well. Heat will unfortunately degrade those microplastics. We'll have more PFAS, unfortunately. So as we think about the amount of plastics that are used by the healthcare industry and by ourselves individually, we can actually have other choices and be good role models in that. So in summary, our next steps, I hope, will be collaborative work. I hope we can lock elbows to be able to think about solutions that are science-based, to understand that science at the molecular level as well as at the epidemiological level to affect individual health and public health. We can involve ongoing programs of disease surveillance, large-scale screening, remain informed about omics technology and exposomics, help with clinical medicine and practice, get harmonization of data, share data, and including the National Academy of Medicine, the WHO, the UN, CDC, EPA, many others are working together in this field and making sure that we harmonize that with developing health indicators that we can watch and that we can watch over time in the short term and long term to test solutions. So I'll stop there. These are my recommendations for change to transition to healthy, sustainable practices, remove fossil fuel subsidies, talk to the community, find out their needs, increase access to healthy transport options, strengthen the public healthcare system, talk to policymakers, invest in healthcare recovery and prevention, and green areas and buildings. Thank you so much for your attention, and I'll take questions.
My question actually relates to air pollution, dust pollution. And as I mentioned earlier, there's a massive bridge demolition going on in the city of Providence now, affecting East Providence and many neighborhoods in Providence. And we know quite a bit about PM 2.5 effects on lung function. I'm a lung doc, but I don't know that we know that much about concrete and silica particles. And could you comment on the extent of knowledge of that type of exposure?
Yeah, Sharon, it's a really great question. So, and PM 2.5, particulate matter 2.5 microns or less, the reason we care about that is number one, because we can actually measure it. So, but if we can't measure it, we can't monitor it. So that's the other problem with cement and other issues. 2.5 microns or less gets into our lungs. So that's why we pay special attention to it. But there are other particles like ultrafine particles, gases that also get into our lungs that aren't necessarily measured in PM 2.5. So that's one of the first issues. We want to make sure that everyone thinks that sight unseen is truly sight unseen. And so we should think about that. And to the other part of Sharon's question about what do we know about cement and demolition, unfortunately, some of our best data came out from 9/11. So Phil Landrigan from Mount Sinai has a lot of data about what happened during that one acute event. We know that cement is also toxic in and of itself because the chemicals used to make cement. There are some better cements, but that's not what's probably in the bridge. So I think your question is a good one. I can try to get you some papers and ask Phil if you'd like, because he really is the best one. But knowing that, what I have read is that it's more toxic than typical air pollution because of the toxins in cement and the organic compounds that are released when you demolish the cement. But I can find some papers for you if that's good. Thank you.
Questions?
Thanks so much for that great talk. I had a question about, of course, one of the big challenges is that in developing countries, the issues, you talked about some wonderful solutions here in the United States for improving health. I was curious, I was just in the Philippines, and the air quality around the city of Manila is really hard to intake. Just curious about some of your thoughts for how we help our developing countries.
Absolutely. It's this very important concept of just transitions. And we have to be so careful because already we've had this attitude to some extent of extraction for many years and colonization, and the countries that have suffered from that are dealing with climate change, and they also are dealing with energy sources that are potentially more dangerous to their populations. So with that, I can say that people are really struggling and working together. My communications with the WHO, I spent a year there. They are very much working with the countries like the Philippines, like countries like Indonesia, India, because many of the people are suffering, and especially in Africa, where they've contributed the least to greenhouse gases. So Vanessa Kari, who's Senator Kari's daughter, also a physician, also now works at the School of Public Health at Harvard in Boston. She's putting together this Climate Action Fund and specifically working for the Global South and talking to those countries. And she, among many, and many of you, if you want to get involved, please let me know, to be able to understand where they're coming from and not expect them to be able to transition so quickly, but that it has to be a staged approach and something that comes from them. I think actually to the Philippines credit, they also have been, in my mind, these communities have been the best at building resilience to climate change because they're under resources and have to be brilliant about solutions with lower amount of materials. And so we can learn a lot from them as well. So I hope that interchange across these countries will help. Does that help answer your question? Yeah.
That was a great talk. Thank you. This is Gaurav Chaudhary from the VA. So couple of questions I have. One was obviously, you mentioned there are all these things happening together, but when we study one thing at a time. except for the exposome, and which is relatively new. And so our solutions that we're coming up with, how do we ensure that's not just affecting one thing, but affecting more than one thing at the same time?
Yeah, exactly. It's an excellent question because we have to get ahead of ourselves. I know that as scientists, we very much want to stay with hypothesis-based science, hypothesis-generating science to some degree, a lot with agnostic and machine learning algorithms now. But as we think about getting smarter about data science, data is also getting ahead of us. Immense amounts of data. Now, bad data in, bad data out, right? Like if we don't analyze it correctly, if data has been put into the system that hasn't been QA, QC'd, that's also a problem. But within that perspective, there are now better models to be able to understand mixed effects. And that's great because we have so much training now in data science and bioinformatics and mixed effects models and geospatial learning. But with that, we also need to think, like you're saying, when we look at solutions, making sure that we don't lose sight of the fact that if you're looking for asthma improvements, you might actually see blood pressure improvements faster. But if you're not looking for it, then you'll miss that. So what I would implore is that as we think about solutions, that we try to be agnostic to some degree. We can have a hypothesis, but make sure we're testing other ulterior hypotheses. Because in order to test a hypothesis, you need to disprove the null hypothesis. And within that, you can also now, with the way that we can do data science analytics, look at many different null hypotheses at the same time. Does that explain? Or does that help answer your question?
No, absolutely. I think it was also more of a comment in some ways,
Yeah.
because I think we have to move towards that. If I may ask another question, there's another one over there. We talked about policy and the role of foundations and nonprofits, and that's where majority of the work has been done. What do you think private industry needs to play a role in promoting positive changes in the environment? Because I think, as we all know, that's probably going to be much faster than just by public funding of these things.
Great comment. The World Economic Forum, the Delphi Economic Forum, across the globe, there are certain companies that are coming to the table. We have a climate and sustainability executive ed program, and we've got 200 chiefs, executive officers, or others from other companies coming to that. So there also has to be a training. But to your point, there are some industries that are obviously on the list of 2 standard deviations from the norm in terms of being early adopters. And then you have others that are the other way, that are still deniers of this and contributing a lot to plastics and greenhouse gases. But you have the ones that are in the middle. And those are the ones that I hope that as we can train the new generation, as we really try to train businesses to be accountable and responsible, and they can also profit from some of these new technologies. So to have them think about these just transitions, to be able to know that as we think about our economy and as we think about the economy of going green, it actually is beneficial in the long run. And to be able to keep those comments made and to keep the economic arguments to these private companies in hand is important. Because, of course, as any industry, for example, coal mine workers, that will need to transition, and we need to take care of the coal mine workers. But the industries that invest in that hopefully will see changes in themselves to adapt to other practices to help other energy practices. So these are the conversations I hope that we can instill so that we as healthcare providers and as scientists can help businesses change their mind if they need to be changed.
Thank you. Thank you for a great talk. This is a little bit of a self-introduction of my colleague Alan Just and I. I'm Teresa Shireman. We were just awarded one of the P20s to study climate change and aging.
Congratulations.
And set up a new center here at Brown.
Yay, exactly. Round of applause.
And we're from the School of Public Health. Alan's in epidemiology and environmental sciences, and I run the Center for Gerontology and Healthcare Research. And so we're very excited about being engaged with this. We're looking forward to partnering with you and the other CCHIs. Yes. But I wanted to say this now before we go to break, because this is an opportunity for networking both with our colleagues around the state and with the IDEA folks. So please feel free to come up and talk to Alan and I if you have interest in what we're doing with the Chair C Climate, Health, and Aging program here at Brown.
Thank you so much. It is a great networking event too, and I'm looking forward to meeting you.
To my team, I've already got her number.
Thanks, Dr. Nadeau, for such an informative presentation. As someone working with adolescent and young adults and looking at the rapid rise, 79% increase globally of youth with cancer, can you speak about the possibility, probability of climate change and ways for us to move forward?
So, and this is the 79% increase in different types of cancer or total cancer? Yeah, exactly. So this is an issue. This is a really important one as we think about the contributions of climate change, air pollution in specific, to chronic diseases like cancer. And I was mentioning the one Lancet article that showed that even after 5 exposures of a wildfire, smoke only with 100 AQI or more, you can see increases in adult population with brain cancer, lung cancer, and thyroid. But this is a key question. And I think the epidemiology is there, but we need to help understand when it starts. So we've been looking at cell-free DNA across the Fresno group because we actually start in pregnancy and then follow them for 25 years. So if anyone's interested, we'll be doing some cell-free DNA work to be able to think about what are the exposures, and we can only look at associations that are associated with potential cell-free DNA changes that could then predict cancers. But what I'm saying is that it would be good to catch those early to prevent the complications of cancer. As to the mechanisms, they could be many-fold. There are so many of the pollutant toxins that can intercalate into the DNA, that immunosuppress, that increase infection rates, but also reduce the immune system so that cancers could potentially grow. And leukemias and lymphomas are also increased in areas of the world with water pollution issues and pesticides. So I think all of these things are contributing potentially, but I don't know all the mechanisms yet. But I hope that if we do design a study, we might be able to think about that together as we think about what could we do to try to get ahead of this and prevent the worsening of cancer. Does that help answer your question?
Over here. Thank you for such a great talk. So just a couple questions. The past 4 years, we've had a bit of a nice existence as far as getting regulations in place, for example, for drinking water and PFAS. With that said, the NIEHS pay line, for example, has been very tight, especially for RO1s. They're starting to decrease some of their programs that support young investigators, such as the ONES Award. There's talk that maybe the Victors won't be offered. So going forward, how can we kind of maybe advocate for funding for NIEHS, as well as now looking forward to a potentially very different political climate?
I wish I had all the answers to those questions.
I don't expect you to.
But I think from what I've been told, and I talked to Rick Wojcik, he came to visit and he's the head of the NIEHS. He's lovely. And I think change happens. We have federal agencies. We have the Chevron doctrine as to how the EPA will change. We'll have to see. But importantly is that I would urge all of you to bring science to policymakers. You can call it advocacy, you can call it impact, whatever you want to call it, but it is our duty and our right and our knowledge base, if you feel comfortable, to be able to go to your local representatives, either in Washington or here in Rhode Island in your state capital, and importantly is discuss these issues that are coming to mind. And you are trusted individuals. A lot of the legislative aides rely on your voice. You know more than you probably think you know. And importantly is schedule a visit And it helps to say, we need more appropriated fundings with NIHS, right to the head of appropriations. She's from Washington State. She is very much an environmental protection type person. So I think her name is Patricia Murray, but she's the head of appropriations right now. And you could write to her and say, hey, when you're thinking about appropriations for congressional funding, think about making sure NIEHS is part of that picture. It is a shame that the one's funding is reduced and whatnot, especially with joint EPA NIEHS funding measures. There were many back in the Obama administration. I'm hoping that they can come back. So I think your question's a good one. I don't have all the answers, but at least we can try to be some of that change and voice for that change.
Well, thank you so much. Thanks for this very I think we can get going. So it's my pleasure to introduce our second keynote speaker, Dr. J.P. Walsh, who is a professor of oceanography at the University of Rhode Island and in the Graduate School of Oceanography, and was previously a director of the CRC based at URI, which is Coastal Resources Center. He will be speaking to us on a topic that is close to home, given that we're the ocean state and within spitting distance of the coast at all times. The title of his talk is Coastal Challenges in the Past, Present, and Future, from Major Storms to Microplastics. Please take it away.
Thank you so much. It's a great pleasure to be here. I'm going to talk a little bit, there we go, about storms and microplastics. And I thought I would start out with a few headlines. The first are, the two at the top are from the early 20th century. And you can see that then we were facing these challenges of pollution and storms. You can see on the left, talk about hundreds of thousands of dollars worth of property has been irreparably destroyed, right? This is the reality of our coast in Rhode Island. And of course, there's been a lot of success stories of responding to those challenges. And on the right, you can see a headline from the Great New England Hurricane in 1938, which caused a lot of death and destruction along the East Coast. So these issues have been going on for a long time. On the lower part of the slide, you can see some of the headlines from our recent hurricanes. Helene and, of course, Milton have done a real number on Florida and states to the north. And as many of you have probably seen in the news, concerned about plastics in our ocean. More plastic than fish. That's a pretty scary estimate. So here I'm going to really focus the conversation more on Rhode Island, tell some stories about our coast, and put some of these issues in perspective. Shown here is a picture of the Edgewood Yacht Club. Here it is being engulfed in a raging storm. This is Hurricane Carol in 1954. Powerful wind and waves did a real impact along our coast, where we were looking at storm surge of over 14 feet in Narragansett Bay. This ended up destroying hundreds of homes and buildings and led to a lot of deaths. These events that we have had in the past are going to occur in the future, and that's something that we need to always have in our mind. It's not a matter of if they are going to occur. They will occur with climate change and otherwise. They are going to be happening. And that's just an unfortunate reality of a coastal living in the ocean state. We are, the state of Rhode Island is really progressive in its management of our coast. And one of the tools that the state has developed, the Coastal Resources Management Council, in partnership with researchers at URI and others, have developed something called Storm Tools, which is a tool that allows homeowners, property owners, to evaluate their risk to things like storm surge. And shown here is a map of basically from Storm Tools. Well, you'll notice quickly when you look at the map, look at the number of homes across and buildings across this landscape today. It's really impressive. The upper left there is the position of the Edgewood Yacht Club. And now one of the things that we've done with Storm Tools is modeled a storm like Hurricane Carol. And we can see what that would look like across this
portion of our landscape and seascape. The oranges are flooding on the order of a few feet. And as you can see here, there's a lot of areas that would be underwater in a scenario like Hurricane Carol today. And this is what we're faced with, these challenges. I'm going to zoom in here on a community of Warren just to our southeast. And here's a picture of Warren. Beautiful community right along the coast. You can see all the boats. Right here along the main street is, this is called Water Street, maybe appropriately. And that's because this is the storm surge prediction for this community. And I got to give hats off to the town of Warren because they have been one of the most proactive communities in our state. They've received really statewide and really nationwide attention for their recognition of their risk and taking action to move parts of their community. But you can see the level of risk in Warren, and it is a serious concern. So if we think about risk as basically likelihood times the impact, one of the things we can first highlight is, well, what's the likelihood of having another event like this? Shown here is a young man looking over downtown Providence during a past hurricane. What's the likelihood? It's going to happen. Yes, it's low probability that we might experience one any given year, but this type of event is going to occur. Fortunately, in Providence, we now have the hurricane barrier, but communities outside aren't that lucky. The other reality is that there's a lot that will be impacted today. We've got our coast is widely developed, as I've already shown. One of the things that in Rhode Island we're fortunate is that we have this beautiful ocean coast. We have Narragansett Bay, and this coastal system has fueled our economy. You've probably heard about this, the blue economy of Rhode Island. We've estimated this provides on the order of 10% of our jobs, billions of dollars of our economy annually connected to jobs that are linked to the sea, shown in these images. So think about if we have an impact like a Hurricane Carol today, what sort of ramifications that's going to mean for our communities. We did have a Hurricane Sandy in 2012, but that was really a brush because it made landfall in New Jersey. Well, it might not go that far. Walking too far. There we go. So climate change is real, right? And we heard, thanks to our great previous speaker, Dr. Nadeau, who highlighted how temperatures are rising, seas are rising. Shown here is an older NOAA prediction of sea level rise going from 2,000 to 2,100. By 2050, depending on what model you use, we're looking at a couple feet here in Rhode Island by 2050. I mean, that's not far off, right? Hopefully the Washington Bridge will be completed by then. But climate variability has also increased. You've probably heard the expression global weirding. So yes, warming's happening, but the globe is getting weird, and we're having all sorts of intense rainfall, intense drought, and that's leading to the challenges that we heard about earlier. Of course, one of the concerns is we have this potential for more frequent, strong storms, and those can cause these incredible impacts like we're seeing with Helene and others around the world. So we need to be thinking about our resilience, and this is a term that gets thrown around a lot, and I wanted to give a couple definitions to it to get us thinking. So NOAA describes it as the ability of a community to bounce back, and while that's a nice way of framing the idea, it does make me a little nervous because I do think we shouldn't always bounce back to the way we were after we have events. Those should be real times when we reflect and maybe revise how our community is living and functioning. Also, below we see the definition from the IPCC, the Intergovernmental Panel on Climate Change, and they highlight the capacity of social, economic, and environmental systems to cope with hazard events, disturbances, or trends. And I think that that's a really important definition because it highlights, we often think of the natural hazard itself, right? The incredible waves and storms or rainfall. But of course, that's all superimposed on a complex social and economic system that is variably be able to deal with that event or be impacted by that event. And so we really need to be thinking about the integration of the event and our social and economic system. So here are just a few headlines from newspaper articles. These are, of course, linked to published literature. That's one thing that as researchers we should be thinking about. Our research often gets translated into the public, and that's valuable, right? That makes people aware. These are some examples. Hurricane deaths concentrated in vulnerable counties. This is something that certainly we're aware of. Those that are less sort of resourced or able to deal are often more impacted. Additionally, they're often impacted harder. So power outages are something that we typically see when we have events that affect areas, winter or summer. And they often are worse in underserved communities. They last longer and they can be larger scale. So this is something that it's not just that the community might flood more, but it's also the sort of ramifications of that flooding may be more longer lasting. And also, as was nicely highlighted in the previous talk, the mental and the psychological damage of these events is real, right? People are being traumatized. I remember, unrelated to really climate change, in New Zealand, I was there after Christchurch had a series of earthquakes, and there were so many occurring that the community had become terrified. Kids wouldn't be able to eat dinner with their parents. They'd want to eat under the kitchen table because they were afraid of an earthquake occurring during that meal. Of course, that's an extreme event, but some of these events, in especially areas where you're getting repeated exposure, are really going to cause trauma to our communities. So here's a nice slide that was shown in the previous presentation, and I'm happy to show it again from the World Health Organization, because it shows climate change at the top. Many times we think about climate change and the extreme weather, the storms, etc. But what's really important, and as a natural scientist, I always have to sort of remember and remind people about, is that the vulnerability of our communities is so critical. And so while we can focus on doing better modeling and better storm predictions, that's usually not the problem. In many cases, we know storms are going to impact an area or that there's an event happening. It's often responding to the communities that are really in need. Additionally, we need to think about what type of exposure we have. Yes, we have people and we have property, but we also have a critically important health workforce, infrastructure, energy, water systems, and so on that support our communities that can be impacted in very odd ways when we have various climate-related events. And of course, together, these affect the health outcomes. And so, yes, there can be direct injury or mortality, but we also need to be thinking, as was also nicely highlighted previously, about waterborne diseases, vector-borne diseases. This summer in Rhode Island, we're hearing about EEE as a concern. In South Kingstown, they were dumping spray on my community, basically, for fear that that is expanded, in part because of the warmer conditions, creating a better environment for vector-borne diseases. So, so many things to think about, and the infrastructure is critical as well. So I thought I'd give you a little bit of background on me and where I came from. I was born in New Jersey and raised there. Shown on the left is a picture of me cleaning up after a hurricane. And I remember as a small child being amazed by this incredible event that just whipped the trees and brought a deluge of water. And so I was so eager to get out there and clean up with my broom. And then later in life, I had the opportunity during my PhD to go work in the remote areas of Papua New Guinea. This is me collecting cores in Papua New Guinea to study how material moves from the mountains of New Guinea into the oceans. And that, of course, that's transferring carbon and also pollutants, unfortunately. But that work has really helped motivate me in what I do today. So as I mentioned, the work that I did in my PhD was really focused on this land to sea movement of material. Probably something most of you never think about is how sediments erode from mountains and get into the ocean. But of course, that's a process that we still don't understand very well. So imagine how we're going to understand the transfer of pollutants like PFAS and plastics. There's still a lot to understand. Shown here is a picture of a simple picture illustrating reservoirs of storage, processes governing transport, and ultimately this can build up on the seafloor, which is a nice tool we have, the geological record, to understand changes of our system. So I'm currently director of what we call the Coast Lab, and our work is pretty simple, right? We study the coast, how it's changing, but we're also working towards sharing that knowledge, building capacity locally and internationally. So on the right is a picture just from a month ago. I was in the Philippines, where we were working with the Philippine Space Agency, government organizations, academic representatives to talk about how we map habitat changes from space and how that can be used to help guide management. And on the left is a couple of my students, one Victoria Fulfer, whose work I'll be talking about in a little bit on plastics. But here, she and Jake are taking a break from beach surveying. We've been, at University of Rhode Island, we've been doing a beach survey of our southern coast beaches since the 60s. And that is really sort of simple science, but it helps us understand how the coast is changing and eventually evaluating risks for communities. So I like to always include my thanks slide so I don't forget. Of course, the students are a foundation of effort for all the work that I'm talking about. There's a lot of collaborators that I'll be mentioning some. The Coastal Resources Center was a great source of inspiration and collaboration. Staff and administrators really fuel this work, and funding agencies. I'll note a few, certainly others. I'll also talk about public engagement shortly, but I want to thank Brown, the organizers of this terrific event, and of course all of you for being here. So there we go. Okay, so one of the things when we talk about emergency management, we often talk about the 4 phases of management: mitigation, preparation, response, recovery. And of course, in those phases, there's so many different things that we can and should be doing to either prepare or respond or recover from events. A lot of the work that my lab group does and many scientists do focuses more on the mitigation side. How do we get better science to help inform the public, to identify vulnerability, and so on? But of course, we also need to plug in and do contribute to these other phases that I've mentioned. I'll stand closer. So for those of you that maybe don't get down to the coast as often as you'd like, I'll bring a little bit of the reality here to you, which is coasts are beautiful, but they are dynamic. And shown here is a few pictures of impact from Hurricane Sandy. The reality is storms are occurring pretty regularly. The seas are rising, and humans are doing all sorts of manipulations of our land and sea, and that's affecting how the coast works. One of the things that we do know, because of dozens of years of student research and faculty work, that our shorelines are eroding, our coastal communities are increasingly vulnerable, and this is a big challenge that we'll talk a little bit about. So I'm going to introduce a couple projects here. I'll start with one that's focused on basically New England hurricanes and nor'easters. This project is funded by the National Oceanic and Atmospheric Administration and involves really state-of-the-art computer modeling to model storm surge and coastal dynamics, as well as coastal measurements. That's kind of where I come in. And another key part of this is engagement. One limiting thing from this project is social science. So it's largely a group of natural scientists and engineers working with public engagement experts to discuss community concerns, to design models to understand how communities might respond to storms and sea level rise. And pictured here is a visualization from a researcher at Penn State illustrating how a Sandy-like storm may cause flooding in the community of Charlestown, Rhode Island. And we've all probably seen storm surge models. Usually they're not done in such a sort of majestic way where you can see three-dimensional houses and storm surge models. But this is an example of tools that we're creating to help communities understand their risk. So one of the things I really need to emphasize in this talk is that we need experts and we need time and funds dedicated to engaging the public. It is time-consuming work to discuss, to understand the issues that communities are faced with. And shown here is my colleague, Pam Rubinoff, during COVID, leading a dialogue at the Cape Cod National Seashore headquarters, discussing some of the challenges. We've engaged communities in all sorts of ways to both understand their concerns and share our outcomes. Down here is a picture of one of my colleagues talking at the Charlestown Town Hall, illustrating some of the work that we've done, talking their challenges of their coast. And right now, well, I'll get to that in a second, they're already having to take some action. So this is a picture that I took a couple years ago when we had one of these powerful winter storms. It actually wasn't a nor'easter. It was actually dominantly wind and wave from the southeast. And here's a wave hitting my town beach, basically destroying the sand dune in the process and leading to flooding in the community behind. It's events like these that are coming a little more often and causing a little bit more problems for our communities. So let me talk a little bit about the modeling that we're doing. So we use some pretty sophisticated modeling to do real-time, well, not sometimes real-time, sometimes sort of creative modeling of storm systems. And I say creative here because what we've modeled in this case is a Hurricane Sandy-like storm with an additional 1 foot of sea level rise. And I need to highlight that the modeling here was done by Annette Grilly. Our storm surge modeling is done by Isaac Guinness and his team. But what we're going to see here in a second is, I'm not sure how to do this with the pointer. Oh, there it is. So as the model runs, the dynamics of the coast are affecting sediment transport. That leads to overwash and effects on houses. And you can see here, this was the Charlestown Breachway that, in fact, was breached by this theoretical storm. So just this one event, again, this was with additional sea level rise, but caused sort of a myriad of impacts and concerns for this community. And what was interesting is this sort of model was done in the very sort of beginning of our project. And as I just mentioned, we had some storms that allowed us to study more recent impacts. For example, in December 23, that storm that I showed you, that breach that the model predicted for a Hurricane Sandy-like storm did in fact occur in the town of Charlestown. This is their breachway. Boats normally navigate here. The ocean decided to cut that channel off. After that storm, it kind of reclosed, but then last winter we had more storm events and it eroded away. So literally this week, they're doing an emergency repair of that breachway. The town, I was actually surveying that area yesterday. This is part of, the town trying to maintain this critical gateway to the sea, which is important for its blue economy and its community. So here's another example. I'm not really going to show much data from the work that I do, but here's a master's project, Best Points. Last year, we did time series drone surveys where we can do imaging and then three-dimensional modeling of the coast and how it changes over time. You're seeing an image from November 10th at South Kingstown Town Beach. And to help you out, I kind of quickly drew in a boundary between the sort of the beach and the vegetated area behind. And what you'll notice, this is just 2 months later. We had several storm events last winter that caused incredible erosion of this area, over 20 feet of erosion along this coast. This is a relatively high area, actually. Additionally, this eroded away this dune and caused major transport of water that led to flooding of the community behind. So this is the main Matunic Beach Road, which became impassable to emergency vehicles. Obviously, there's a community behind that really wasn't excited about that. That tends to be when the problems occurs during these storm events. And of course, you can see that there was some properties that were impacted as well. So it's these events, sometimes they're not huge hurricanes, that still can cause trauma to places and some of the issues that we've already talked about. Oops. Back. I'm also proud to be a team member on a new project funded by the National Science Foundation called 3CRS. You can see the longer name of the project there. 3CRS is being led by Dr. Emmanuel DiLorenzo from Brown and has a great team involving people from, of course, Brown, URI, and other institutions. The project is multifaceted, and it would probably take me this whole talk to explain the varied work that's going on. But ultimately, the focus is on climate resilience and the health of our communities. And I'm going to give you a few specific examples of what we're working on. So this project is aimed at understanding strengths, but also vulnerabilities and gaps in our knowledge, and working with communities to co-develop tools and capacity to respond to climate change events. And these are not just coastal sort of storm surge events. We're also looking at compound flooding, heat events. We do have Kate Moretti on the team who's been looking at ER visits and other aspects. Elizabeth Fussell is in the back. She's been working at health metrics. So there's a lot to this project. Ultimately, an additional aspect of this is communication. We need to bring our stories of our efforts and the community sort of impacts to the public. And so that's something that we'll be working on through the 5 years of the project. There's some broad goals here: shaping our resilient future, increasing access to knowledge and data, and also doing some hyper-local data collection and modeling. I think that's one important thing that I want to quickly highlight, is that we currently now, our weather systems can do really good job of modeling like a hurricane and where it's going to move in the next, let's say, 24 hours. It's harder to go much beyond that, but that still gives us a good amount of time. But then what that is going to do to a coastal system really depends on the patterns of rainfall, the drainage network, and the human alterations of the system that we've done. So hyper-local data where we're monitoring and comparing that to detailed modeling is really critical to really help advance our understanding of impacts on our communities. And I want to give you an example of this. A couple researchers at URI, Dr. Isaac Guinness and Austin Becker, have developed something called Rhode Island CHAMP, which again has a long acronym that I won't read. But CHAMP is really cool. It's a tool designed for Rhode Island emergency managers to literally, as storms are approaching, they're doing advanced storm surge modeling to predict consequences for critical infrastructure. So they've gone out and surveyed in key aspects of our community, whether it's critical. You can see some of the lists there: security and so much more, to be able to flag what's going to be impacted in advance of a storm so we can better prepare in Rhode Island. It's this system and more that our project's going to be building upon for communities in New England to help them understand how their community may be impacted during storm events. Okay, so now I'm going to pivot to something completely different and take you on a tour of a new problem or it's not really new, but it's a problem that I think people have become a lot more aware of recently. This is a picture that I took a few years ago on the eastern shore of Narragansett Bay, or the Providence River, looking north to Providence. You can see the hurricane bear in the background. This is real. I didn't bring all this plastic and dump it here. It was that bad, and it was really mind-boggling how much debris was on the shoreline. I think I like to bring this back to a great movie in our history, The Graduate. And here you can see a father talking to a young Dustin Hoffman, encouraging to think about the world of plastics as a career. And suggesting that, one word, plastics, they're going to be important. And he was right. This was 1967. Here's time on the x-axis and tons of, millions of tons of plastic produced. This is when The Graduate was released. And look at this exponential growth of plastic production. And notice there is no leveling off here, right? We are producing a lot of plastic. One thing I'll note is that the first plastic was written about, in fact, there's debate about what was the first plastic, but New York Times has this article on a new chemical substance in 1909. And this is the name of the compound, which I can't even pronounce. How could we not be scared when we realize we're producing this and putting it out of the world? But anyway, as you can see, we've been producing a lot of plastic and it's going out into the environment. We've all, unfortunately, seen these images of charismatic megafauna that have been impacted by macroplastic. But these pictures should really get us thinking about what's the broader scale of this problem. And that's what I'm going to talk a little bit about. So obviously, macroplastic is that visible stuff that we see. The microplastics and then nano, which I won't really talk much about at all because we can't really measure those very well in the environment. But microplastics are incredibly diverse. Look at this suite of polymers along the left side. Of course, these often have additives. They come from all different sources of production, different morphologies, different colors, and of course, they have different types of toxins associated with them. This is this soup of stuff that we're unfortunately that's moving through our environment and into the ocean, and that's an area that our lab group has been focused. So how does it get into the sea? Well, it's really just a reality of we produce so much. A lot of that is in the coastal zone, and there's what we call mismanaged plastic, right? Some of it's deliberate littering, but a lot of it's, it's a windy day and the trash cans blow over, or the trucks, not closing all the way and it's pouring out. And that's just, the probability of plastic making it out of where the waste stream into the environment is inevitable. And we estimate on the order of 10 million plus or minus tons go into the ocean. And what a lot of people hear about or have heard about is the garbage patches. Shown here is a map. I'm sorry, I don't have the reference on here, but this is a map of modeled and measured plastic concentrations across the oceans. And yeah, there are areas of high concentration of plastics in discrete areas. But I will say that the more we look, the more we're finding that there's also a lot more plastic. And when we integrate all of this plastic, this only accounts for about 1% of the plastic that we think entered the ocean in the last 50 years. And so the big question is, where is a lot of the other plastic going? And not surprisingly, a lot of it's being trapped coastally, or it's raining out of the ocean and ending up on the seafloor. And that's where the work that I've been doing comes in. But first, before I get into that, I'll talk a little bit about what happens to plastic in the environment. It'll degrade through physical and chemical processes, basically UV light coupled with mechanical actions of wave breaking and other things will break down plastic into smaller particles. It will become fouled by organic material. It'll get consumed by different organisms and turned into, fecal pellets that'll move through the seafloor. It's a complex process and dynamics that we're just really starting to understand. In order to understand the coastal system of Rhode Island, we went out and collected seafloor and shoreline samples of sediment. We took basically a little subsample. We digested that in a heavy liquid to float the plastics. We then counted on a microscope, and we can identify specific polymers using FTIR or Raman spectroscopy. The methodology is relatively straightforward, but it's very time-consuming. Just to measure a sample takes hours. And of course, there's so much, there's so many questions out there of what the contamination is in our environment. So, in order to determine a plastic polymer, we basically can look at it under reflected infrared light, and based on the diffraction pattern, compare it to sample spectra to identify plastic polymers. So that's the basic methodology, and here are some results which were surprising to us. So shown here is a simple graph going from Bold Point, which is where that picture was taken that I first showed, going down to Narragansett Beach. And notice we have shoreline and sediment samples. We don't have a ton of them, but this is what we could get done for Victoria's, part of one of the chapters for Victoria's dissertation. And what you'll notice is that near Providence, we're looking at thousands of particles per kilogram of sediment. Thousands, you know, over 13,000 in some, even higher in some of the samples from Water Place Park. Obviously, you can see a pretty strong down system gradient in the concentrations. And you'll notice that, you know, depending on our data, maybe the seabed has a little bit higher concentration than the shoreline, but that's probably depends on, you know, the sampling and where we did it. Whoops. One of the things that we were curious about is how do we find different density polymers in the environment? And shown here is a figure from the GSAMP, which shows how, of course, different materials are made up of different types of plastic, which have different densities, and we would expect them to be transported and have a different fate. Of course, these plastic particles, or they start off usually as macroplastics, will degrade and fragment and foul, and so even the lightest density particles can end up on the seafloor. And we know that because even in some of our limited sampling, we'll notice on the x-axis here is particle density, and on the y is going from beaches to subaqueous settings. And we'll notice that we see low-density particles are dominantly occurring on beaches, but we also find them in the intertidal and subaqueous system. And that's because, of course, the fouling and the fragmentation that we talked about. High-density plastics, of course, they get moved around in the environment due to the physics of waves and currents. All right, so as we heard, actually both the senators alluded to this one study, which we basically quantified using a simple fit to the data that we have, looking at the morphology of our bay, quantified on the order of 1,000 tons of microplastics in our on the seafloor, the upper 2 inches of Narragansett Bay, which is an impressive total, given that I think we never really imagined there would be very high concentrations at all. One of the realities of this is that dominantly about 50% of the plastics is caught in the sort of upper half of the estuary, and that's of course because of those very high concentrations near Providence. It's a very small area up there, but it's really highly concentrated with plastics in our sediments. And I think that this study, the initial study of just looking at the surface, made us question sort of, well, what if we look back in time? And so that's where the sedimentary record can allow us to investigate that. So we took cores going down the estuary, and I'll show you some data from there. Basically, with a core, we basically put a core into the sediments. We slice up the sediments. We measure microplastic in each slice. We date the core using a combination of isotopes, lead-210 and cesium-134, and we typically also look at the grain size just to evaluate how that might be affecting our dating. And this is sort of an example core. On the far left is lead-210 activity versus depth. From that, we can calculate the accumulation rate of the sediments. In the middle, you can see the sediment and what it looks like. It's a nice, relatively even grain size. And on the right, you can see the plastic concentration and the variation in polymer type. And so notice that the upper sample is really chock full of microplastics, thousands of particles in those upper sediments. And then as you go with depth or time in the core, you see that those concentrations decrease. And I'll show you a couple more cores in a second. Of course, we also see a change in the polymer type. Today, we see a few different, and I'll show you more examples in a second. And going back in time, we typically see much fewer polymers. So here's sort of a take-home figure. On the right are all the cores from the estuary. On the left are some cores from the marshes. And they all show sort of this trend of very high concentrations at the surface, decreasing down to near zero as we go back to sediments that are dated around 1950. One of the interesting outcomes of this work is that the marsh systems, which are shown on the left, if you compare them to their adjacent estuarine site nearby, they had 10 to 50 times more plastic in them. And this is concerning because marshes are a sort of critical habitat for juvenile fish and other organisms. It's where, you know, something like 95% of commercial fish begin their life. Maybe it's 70%. 95 is probably too high. But anyway, point is that marshes are important, and they're really important filters of pollution, as we've heard on other pollutants in the past. Whoa, something bad happened. Yikes. So here we go. Now let's quickly talk about the diversity of plastics. And I think this probably scares me more than anything. This picture is one sample from sediments from Water Place Park. This was dredge material that we were able to sample and then look at the plastics in it. And this Petri dish is full of every sort of shape, size of microplastic you can and color of microplastic you can imagine. This is one of the problems of our plastic issue, is that we can't singularly deal with the problem in one industry. It's coming from so many different sources. And of course, we've measured that as well in our cores. This is, again, data of different types of plastic. On the far left is particle type in one core. In the middle is color of particles in that same core. And on the far right are polymer types. And what you can see is as we go back in time, we only had one or two types of plastics that we see. And of course, the concentrations of those were low. But as we go forward in time, you can see the diversity of plastics is really incredible. And that's reflective of course, the production and use of plastic throughout our society. Now, one of the big questions is, what are the consequences of these plastics in the marine environment? I am not an ecologist, but there is increasing work. First of all, there's been measurements of plastic in just like in the human body, in pretty much all organisms on Earth. We can see here, one of the things that we're trying to understand is at what concentrations are we seeing direct species impacts of plastics. And the research has really shown that for a small percentage of species, there's at the threshold of about 540 microplastics per kilogram, we are seeing some measurable impacts on their physiology and function. So I think this is a concern because when we compare this to the in situ data that we have, we already see this is in the middle there. You can see our samples from the surface of Narragansett Bay, that all the yellow, orange, and red are samples that are above that 540 threshold. And so, again, we're comparing lab studies to field observations, and there's a lot more work to be done to understand what impact plastics are having across our ecosystem. From the smallest zooplankton up to the largest mammals, we know that there are impacts, but how the ecosystem's going to be impacted in the long term is really an experiment that we're in the process of running, unfortunately. And then, of course, many in this room are thinking about the human impact of plastics. And I'm not a medical doctor, but as we all know, the explosion of research is ongoing. And one thing that I will highlight, and when I usually present this work on the marine environment, people say, should I stop eating seafood? Seafood's still very good for you, and I advocate eating seafood. I do think that we do need to be monitoring our seafood for plastic. We need to be recognizing that we eat the meat and not always the gut of the organism that we're talking about. So that's something might limit our intake. But the other reality is that it's not just seafood that has plastic, right? We've now measured it in all sources of protein, table salt, Beer has a lot of plastics. So big concerns. The other reality, as we heard about earlier, is that there's different ways it's getting into our bodies. It's, of course, been, I think, now measured in every organ, blood, and so on. Now the question is, what are the ramifications for us physiologically? And that's probably for all of you to help us figure out. So what do we do about this problem? First, as individuals, we should really be thinking, I would say, less about recycling and more about those other things. How do we reuse, refuse, reduce, and repair items? The less we use, the better off we are. Ultimately, our systems really needs to be thinking about a circular use of the goods that we make. How do we not have a single use of anything, but rather take, once it ends, it's single use, it ends up into some other useful product. So a lot that needs to be done in this realm. And I'm going to go ahead and conclude by highlighting that our coast is really valuable and we all care about it and enjoy a good day at the beach, but it certainly is at risk, and those problems are only going to get worse. So we heard about Helen a lot this year. We're going to be hearing more in the future. I will highlight that there is good things to see and know that there is hope occurring in the system, right? We can look here at the hurricane barrier in Providence and see that when there is an event, hopefully we respond and build resilience to prevent future impacts. Plastic is a big problem, and it's only increasing. At this point, I don't think a bottle bill or a plastic bag ban is going to be the solution. We need to be doing more. I don't have that answer, but I'm really happy that our senators are both, particularly Sheldon Whitehouse, who's been really vocal on this problem, and we need more of you to communicate to the greater world of these problems. So please share what you've heard today, both from me and the great previous talk. There are a lot of problems, but we should have hope. It all comes from the great research and education and communities that we live in. So thank you very much.
We have time for questions.
Remember, there's plastic in beer.
So about a year ago, there was an article published in the New England Journal from some Italian pathologists demonstrating the presence of microplastic particles in atherosclerotic plaques of humans with various arterial diseases. This, to me, I have done vascular biology, and I was really horrified when I realized I had no idea what the biological mechanism was and in fact, are the microplastics a causal or a mitigating or a worsening influence in the process of atherosclerosis? Do you have any comments on
I
that?
have no idea, unfortunately. I'll be full disclosure, yeah.
Effects on human disease are it's pathetic. We need to learn more.
Dr. Nadeau, please.
Just a quick comment, and please, if anyone else is interested in this research, so we have the cohort, the nurses' health study and the physicians' health study. So we're going to be looking at their plasma and now studying microplastics in the plasma and looking at the degree by which it's associated with coronary as well as carotid artery disease, because that New England Journal article, as well as many others, sort of woke us all up. But importantly, they're the breakdown products of plastics which actually activate the endothelium and lead to increased embolism as well and platelets. So we're looking at that, but that might be one etiology, but maybe not everything.
Great to hear. Good. Yeah.
Thank you. I'm sitting here listening to you, and we don't have single-use plastics in my house, and it was very easy to do. It was not a hardship. And I just feel like that message isn't out there because you walk into a Target and it's rows of Ziploc bags and plastic detergent bottles. And so how can we get that message to like industry to stop making these products and to our politicians to maybe enforce things in industry, because that's kind of, I feel like, where it's coming from, right?
Yeah, that's a great question. I think, I can't make that same claim that there's no single-use plastics, and I'm drinking out of a single-use plastic. So, but that is, I think, one of the big challenges. I think it has to be, a lot of times we think top down, right? That it's got to come from government to put these mandates down. But I think as a population, we really need to start thinking about our choices and maybe our pressures, right? Reaching out to, as we heard earlier, reaching out to our delegation, putting some pressure on these, shining a spotlight on these problems. But yeah, I don't think a simple, easy answer on this one. And as you can see, there's been really little action despite awareness of this growing problem. Yeah.
Thank you for this talk. So my question is kind of a related one. So one of the ways we can influence policy and create a pressure is provide evidence that once you do something, things do get better. So are there any examples or, natural experiments where our cities and ocean state that have changed the way they deal with plastic and has an impact on the ocean health?
That's a good question. I don't think I know plenty of examples of communities and countries that have changed, documented sort of reduced impact on the marine system or the environment anyway. I have not seen that. It also might be that I haven't, scoured the literature looking for those examples. So I do, in Africa, there's been several countries that have banned plastics. And I think that in Europe, the EU is being really progressive in this area on single-use plastics. I think we'll start seeing that now that we see more drastic action and the ability to measure it over time. But I don't know. Does anyone else have a good example, or anyone? No? Yeah. And she had almost all the answers, so that's saying something.
JP, that was a great talk. Thank you. I have a question on definition of MP, right? I noticed that the minimum size is a 5 millimeter.
Yes.
Right?
Yeah.
In previous talk, we talk about PM, right? Micron sizes.
Yes.
So 5 millimeter, is that by convenience of counting, or does it have any scientific justification? And I'm just curious.
Yeah, that's a great question. I don't really know where the 5 millimeter, because I'm actually a geologist and we look at particle sizes using different sizes. On the measurement side, in environmental plastics, it's really hard to measure things, at least from environmental samples. On the FTIR, we can get down to sort of microns, maybe usually tens of microns. We tend to sieve our samples at around 62 microns, which is sand-sized in geology. Measuring below that is difficult. We can do like GC mass specs of like whole samples and combusting them to look at sort of measure loading in samples. But this is sort of a limit in the environment of what we can measure. But the 5, I'm not totally sure who made up the 5 millimeter, but it's just become an operational definition.
Follow-up question. So I guess you use some sort of a molecular sieve to filter off all the smaller ones, and then
we use a dense fluid. So sodium iodide, we basically mix the sediments in sodium iodide, and that floats the less dense particles. We do a little bit of acid treatment to remove organics so we could better identify it. But keep in mind, like, sediments are a matrix of organic and inorganic materials. It's really hard to kind of pull those plastics out. So this has been another big debate, is how do we measure in the environment? Everyone's using a sort of a different methodology. So there's really no sort of standard. But of course, you want to measure as detailed as possible, but if you spend all your time measuring one sample, you won't get the diversity of samples that we need. Of course, the measurements need to be accurate, but anyway, there's some limitations right now on the measurement side of environmental samples. Yes?
Thank you for this talk. I have a question on the line of biodegradable plastics, and I wonder how they fit into this conversation, especially in terms of the environmental impact those may have as well.
Yeah, I mean, biodegradable. So right now, my understanding is that it's an interesting space and everybody wants there to be biodegradable plastics, but I don't think there's regulation over what is a biodegradable plastic, and so people claim, or companies claim, certain things. It's an area where, you know, there's every now and again you hear announcements, oh, new perfectly biodegradable sample or polymer, but I think there's always some caveat, and it needs the right conditions, or et cetera. There has been some really good work. An NSF project funded some scientists trying to design new plastic for stuff that's going in the ocean, and they've been really meticulous about looking at the breakdown of their polymers in the marine environment, measuring the time, and feel confident that they have a good, I don't know the details of it, but as far as in the commercial space, I get a little worried that, what we buy and is being produced is really not, in many cases, that degradable. It really depends on the conditions that the plastic's ending up, whether it's going to break down all the way. Yeah.
Thank you.
Thank you. Thank you. Thank you so much. Thank you.
People can take their seats with their lunches and get started. I think we have a really incredible list of panelists here who will be kicking off some discussion around health effects of environmental change, both from Brown as well as URI. So just to introduce them, we have Dr. Angela Slitt, who's a professor in biomedical and pharmaceutical sciences at the University of Rhode Island. She holds an appointment as research health scientist at the VA Maine. Dr. Slitt has 29 years of expertise in the field of toxicology, mostly focused on mechanisms of liver injury and disease. Her research program has focused on environmental exposure, specifically per and polyfluorinated alkyl substances, which is PFAS. And we've all heard about that in the news, and how they can affect the liver function and affect hepatic proteome. Specifically linking them to various kinds of liver diseases and looking at molecular mechanisms that dictate their absorption, excretion from the body, and also lactation. She has more than 100 publications in this area and funded through the National Institute of Environmental Health Sciences to study PFAS-related absorption and excretion. Next, we have Dr. Just. Dr. Just is the Nazareth Ferguson Family University Associate Professor of Public Health and Associate Professor of Environment and Society. Is an environmental epidemiologist, and his areas of research includes children environmental health, and now aging population as well with the new center. So it's cradle to grave, pretty much. Remote sensing, air pollution modeling with satellite data, climate and health epidemiology and epigenomics, and how better estimates of quality of air we breathe and the temperature in our neighborhoods reveal previously underestimated exposure disparities and health impact. He uses NASA satellite products and spatiotemporal machine learning to reconstruct environmental exposures, to find particulate matter, air temperature, humidity, and epidemiological studies and cohorts across large registries, both in the US and Mexico, and is funded by the NIH. Next, we have Dr. Fussell, Dr. Elizabeth Fussell, who is a professor of population science and environment and society. And she is a sociologist and a demographer who studies environmental drivers of migration and health and disparities in these outcomes. She has published extensively on the effects of Hurricane Katrina on the population of New Orleans. She's currently studying population changes in Puerto Rico associated with Hurricane Maria and other shocks. Her research is supported by NIH and NSF and the Russell Sage Foundation. And finally, we have Dr. Daphne Koenig-Mitchell, who is a professor and vice chair of research in psychiatry and human behavior, and also vice chair of pediatrics research at the Alpert Medical School. She's nationally recognized expert in childhood asthma and the role of urban environment on asthma and health disparities in asthma. Again, she has over 100 publications. As research is supported by NIH by multiple R01 awards. She leads 2 centers providing research opportunities to early career faculty with emphasis on underrepresented faculty. She served on NIH review panels and a standing member of a CSR study section on community level health promotion, and serves on editorial board of the Journal of Pediatric Psychology, Journal of Allergy and Clinical Immunology. So I think we have a really great panel here with interests across the board and that relate to the environment. And so we're going to have some questions for the panelists, and then hopefully that will stimulate some cross discussion among the panelists, as well as questions from people in the room. And then I think we're also monitoring the chat for people on Zoom. So maybe I'll start with you, Dr. Slit, and can you just briefly describe what is the impact of PFAS and forever chemicals on human health?
Sure. Okay. So that is a big question. So first of all, just to recognize that there are thousands of extant PFAS currently being detected. Of those, we only really know about the human health effects of a handful. And the health effects for those are anywhere from cardiovascular disease, issues with liver disease, hypothyroidism, other endocrine disruption, as well as also kind of early in life, reduced birth weight. There are many adverse health effects associated with PFAS exposure.
Okay. And so what would be the role of, say, diet or antioxidants in mitigating the impact of some of these chemical exposures?
Well, so, I mean, right now the literature kind of shows that there's some evidence that weight loss can mitigate some of the health effects of PFAS. But largely right now, I think that's kind of an untapped area of exploration for PFAS in general. So when we think about mitigating PFAS exposure, there's really limited information. One is that we know that blood donation actually is a good way to lower PFAS exposure. Obviously, with that said, there's some ethical issues around that. Second of all, there's a very recent study that came out of Denmark in 2024, actually collaborators of one of our STEEP Superfund Center members that looked at the use of the medication cholestyramine, which is a bile acid binding resin used a long time ago to lower cholesterol, and showing that when you can disrupt enterohepatic circulation, you can substantially lower PFAS levels in individuals who have levels that are kind of higher than what the National Academies of Science would recommend. Interestingly for us, we study this a little bit in our laboratory, and we've kind of taken an approach that pharmaceutical companies have, which is understanding how drug transporters can interact with PFAS, and if we can disrupt the circuitry around transporter-induced absorption of PFAS, you can lower PFAS absorption, at least in experimental rodent models. And so we actually see use of apple juice extracts, and the antibiotic rifampin is actually able to decrease absorption of certain PFAS, and that has to do with transporter inhibition. And the correlation to that is just that those transporters have clinical implications on bioavailability of certain drugs. So we know that this happens in humans. Yeah.
Really interesting. So maybe from PFAS, we move over to some environmental epidemiology. And Dr. Jess, can you discuss how air pollution and rising temperature can exacerbate health disparities in certain communities? And
Certainly. So we heard the topic of air pollution and heat was raised in some of the talks earlier today, that this is an ongoing trend, that wildfire is exacerbating exposures to air pollution, particulate air pollution, which had been improving substantially in the United States because the Clean Air Act works. And now some of that improvement is both endangered and now we need to better understand wildfire related smoke exposure, because not all air pollution is the same. It depends not just on the concentration of particles, but also their composition is related to their toxicity. So we have more heat, we have greater duration, frequency, and intensity of heat in some parts of the country, especially. But everywhere we have this risk of greater air pollution. We heard about the Western United States in particular, but here in Rhode Island, we had quite a bit of wildfire-related smoke. Those aged particles that travel from Eastern Canadian wildfires, they change in their composition and in their toxicity over time as they travel and as they interact with other atmospheric components. So how does this relate to disparities? Well, there's several ways, but I think sometimes we see maps of the whole United States, and we sort of say, oh, it's kind of all a wash, or there's big wildfires in the West. But actually, there's also a lot of local variation, and that's both local variation of regional phenomenon, and on top of that, there's still local air pollution. So if if we're experiencing wildfire-related or stagnant air in Rhode Island leads to an accumulation of particles. If you're also living within a few hundred meters of a major roadway, you're going to have that extra burden. You're going to have both traffic-related air pollution and the more regional background. And that regional background has been improving, but we also know that where people live is very not random. There's very strong residential segregation. Rhode Island has incredibly strong residential segregation in where people live. And so that's led to big differences in what levels, what concentrations of air pollution people experience, at their homes and where they work and schools. And the same is also true of heat. So we can't think about the health effects of temperature just with the weather station at TF Green Airport, because most people in Rhode Island do not live at TF Green Airport. And so there's substantial variation that can be seen from neighborhood to neighborhood, from block to block. There was a shout out earlier today about the importance of trees, the shade that is cast by an individual tree. So tree canopy cools us primarily through evapotranspiration and through shade, blocking that solar energy. That's very localized, and where the big trees are is not random. And so when we think about both, and I will also say, when we've been able to leave in place large trees or substantial vegetated area, that's also something of a block on where we've put our roadways and where we've put our impervious surfaces that hold heat. And so this unequal distribution in green space and in the sources of exposure to air pollution means that there are these really persistent disparities in who's exposed to how much when we think about both air pollution and heat. On top of that, there's many other social inequities that go along with those kinds of elements of the residential segregation. I won't go into all of that, but just that these are societal challenges, but they're also deeply unequally distributed.
So I know you've worked with remote sensing a lot. So what do you think? But there's also other kind of sensors now, proximate sensor in the house, wearable sensors. How do you think these sensing technologies will impact some of the work we do in the future?
So I think that's really helpful, this combination of remote sensing. So I use data from NASA and European satellites. You have sensor networks. So those could be low-cost sensors, or they could be sort of the higher quality regulatory grade sensors. In Rhode Island, we only have a handful of regulatory grade sensors for air pollution. And states and local agencies are required to monitor air pollution, but they have to do it in a way that's, it's just frankly too costly. So there's a station that sort of tries to get at what's happening in urban areas in Rhode Island. But when the bridge went down last, December, we didn't really have monitors that were close enough to tell us about something that was atypical, right? To be responsive to this question, okay, when 90,000 cars can't get over that bridge and they're all being piped through East Providence, what happens there? We didn't have, we don't have the density of sensors to answer those kinds of questions. Satellites can be useful with great limitations. We don't get data on the air pollution when it's dark out, which happens regularly. We don't get data when it's cloudy. We don't get information about what's happening inside your home, which is where a lot of breathing occurs. So we're, it's kind of piecing together different proxies to try to understand that. But I think that distributed networks are going to be an important tool when I go back to that point about disparities of not painting too broad a brush, right? So historically, our weather stations were at airports. When you look at the long-term climatologically useful records, many of those are they're not representative of what's happening, inside cities or even necessarily representative of anything other than airports. And so we need to better understand what's happening where people live, because that's what's relevant to their health experience. Are they able to cool down at night and, get restful sleep? Those kinds of questions. So I think that this new technologies are very helpful, and there's still more work to be done, and cost is still a major limitation.
Thank you. Talking about weather stations in airports, I know, for the extreme weather events that we've been dealing with, Dr. Fussell, I was wondering how they, like hurricanes and other extreme events, reshape the population health in general, and probably also through migration and other patterns.
I'm going to answer that question by just giving a little bit of background on why I'm here. I am a professor at Brown University, but on the main campus. And as a demographer, what we're interested in is population distribution and change. And so there's a focus on fertility, mortality, and migration as drivers of population change. So I focus on migration. That's the main thing I'm interested in. And it's important because it's one of the most significant drivers of geographic redistribution of the population. So extreme weather events have the potential to redistribute population geographically, but they also have the potential to affect health in the locations where people are most exposed. So that's my vantage point on which I enter this conversation. Having said that, extreme weather events, like the really extreme weather events, like Hurricane Katrina or Helene or Milton, which both just happened, those are pretty rare. And so when we think about extreme weather event potential to redistribute population, it's probably not the most important driver of population redistribution. I hope that we begin thinking about those extreme events in a more anticipatory way and incorporate those risks into decision making about where we live and where we build houses. And so I think that extreme weather events, while we might react to them and they will redistribute population, we can also learn from those experiences and incorporate that into our decision making, both at the governmental planning level and at individual levels.
I mean, there's also disparities in how migrations happen, right? And you say people try to escape one extreme weather event, end up in another area with more potential for extreme weather event, and that's been in the news lately, and the discussion on it and the choices they make. And so, but there are also long-term health consequences for these displacements, and particularly in the vulnerable population, low-income population. So what are some of the considerations there that you have evaluated in?
Yeah, so my research on this topic began in New Orleans, where I was a professor at Tulane University when Hurricane Katrina happened. And that was really a wake-up call to begin thinking about climate change drivers and migration. And because the entire city, we've forgotten this, it's 19 years ago, the entire city of New Orleans evacuated. The only people left in the city were the first responders. And even they left afterwards. And so that was a really unprecedented event. And I'm involved in a study right now using administrative data in the Census Bureau's Research Data Center to look at the long-term outcomes of that event on population health and redistribution and migration. We can see that there were significant inequalities in both the health outcomes and the migration outcomes of the residents of the city of New Orleans. Black residents of the city, and I'm going to just say that race is not the reason why people were more likely to be, Black residents were more likely to be displaced, but the correlates, the socioeconomic correlates of their living conditions, including historic practices of racial residential segregation and discrimination, made that population on average more vulnerable to the displacement effect of that event. It was partly because the areas of the city that were flooded more significantly were where Black residents tended to live. And we often find that racialized minorities tend to live in more environmentally vulnerable areas, whether that's because of pollution or because of zoning, where they're living in areas that are more vulnerable to flooding or hotter. You know, those are correlates that often create these pre-disaster vulnerabilities and also shape the ability of populations to recover their housing, to return home. Their losses may be greater because of those exposures. And so it's really a very prolonged chain of events that create greater vulnerabilities and obstacles to recovery for minority, or for, I should say, marginalized populations.
Thank you. And maybe I'll move on to Dr. Kunis-Mitchell. If we could discuss how some of these changes in weather can impact more of the urban population, and children with asthma, with comorbid conditions such as sleep disorder and other things.
Sure. So my research is very much focused on children's health outcomes, mainly, as mentioned, urban children, and we're interested in pediatric asthma and asthma-related comorbidities such as obesity and sleep health. And we have been following children now in urban areas such as Greater Providence, New York City, San Juan, Puerto Rico. And we've learned a lot from observational research across these settings. Our approaches use everything from quantitative, qualitative, objective, biological approaches, and we're interested in clinical approaches. And we are looking at multi-level exposures. And so this body of observational work has really taught us the importance of looking at kids across the different settings and the role that environment plays. And building our interventions, much of our work acknowledges the cumulative impact, as Dr. just mentioned. It's not just one exposure, but we know that there's an interaction between children's proclivity to be sensitive to these exposures. So we look at atopic status very carefully across children, and we look at the extent to which specific children have a reaction to their environment based on where they live. And I can go on and on about the social injustices that exist in urban environments, and thankfully we've done a lot to change policy and working with the Department of Health to really look at the communities where children reside and spend time in, and their school settings, to understand what are the direct and indirect pathways by which the environment impacts children's health. And I can just mention simply a few direct and indirect pathways. Well, we know, as we heard, extreme temperatures are a direct trigger to children's asthma and their sleep. And we know that when children are both hot or cold, this can have an impact on their nocturnal asthma symptoms and also their sleep quality, how long they sleep at night and their sleep duration and disruption. And there's not much we can do about the temperature changes, but we focus on things that are modifiable within the home environment. So we actually spend a lot of time in their bedrooms and walk around their homes and look at what are aspects of their immediate environment that may make a difference in terms of both the air they breathe and their sleep space and their breathing spaces. And we're interested always on this cumulative impact, again, because we know that not just one exposure, certainly one exposure matters, but it's really, our papers have shown it's the buildup. And so temperature makes a difference, mold exposure. There's clear, direct, robust literature looking at black mold and children's asthma symptoms. That's not anything revolutionary. But what we do, again, is teach caregivers how to modify their environment so that mold is not, prolific in some of especially the children's sleep space, but their bathrooms and so forth. It's difficult. Sometimes we get legal involved, and oftentimes there's only so much that's within the family's control. But this is really, it's really through mold, through temperature changes, through air quality, both indoor and outdoor, that can have an impact on children's asthma, sleep, and of course their physical activity. Many families tell us that they keep children inside with these extreme temperatures, and we know that in some ways that's not helpful because they're not engaging in physical activity. So it can have an indirect pathway on their increased exposure to indoor environments, which can also, if they're exposed to many environmental irritants and allergens, can enhance their asthma morbidity. So these are some of the direct and indirect pathways that we try to understand more carefully in our research. And thankfully, I always think of things from an interventionist standpoint. And I heard the previous speaker, and I was thinking, what are the behavioral strategies that we could employ to make single use? What are the other alternatives that we can provide to families? And that's the way sort of we're thinking about our research. We know that climate is difficult to change, but we focus more on what's modifiable within children's environment.
So behavioral change was one of the intervention you made, education to the family. What are some of the
access to, optimal nutrition, access to optimal healthcare. Many of our, we talk about disparities, and, many of our families don't have a usual care provider. We have an early career researcher here, who's a pediatric pulmonologist, Maytab. She can speak to this as well. And she's an investigator funded by CTR, looking at indoor air quality more carefully and interaction with outdoor air quality. And a lot of our families don't know the importance of seeing a specialist. Asthma is very complicated. It's demanding for all families. And then when you have aspects of management or triggers that are beyond families' ability to control, it makes it more difficult. And so if we can change things like acknowledging or pointing them to, which specialists they can see, or what are clean solutions that they can use that may not be dangerous to their children, what are ways that they could modify mold within their environment, et cetera, that's helpful. And so I look forward to working with Alan in the future as well, because we have some ideas that are formulating.
Yeah, so any questions from the audience before we move on? Got it. Dr. Bujel.
I also have questions. Daphne, I'll be back.
It's good exercise for you today.
Thank you, Hilda. I have a question. I don't know, maybe that's to Daphne, but we heard earlier that overheating might be related to mental health issues. And I've been thinking about this since I heard this, and I don't understand it. Is it because people are sitting together in like more indoor and maybe closer areas, or is there a biological thing that might be messing up with their brains or something? I don't know. I thought it was really interesting, and I'm trying to understand it.
I mean, it really depends on the individual's, predisposition and, their specific, what psychiatric symptoms they're already in play, like if they're already experiencing anxiety and stress, and you have extreme temperatures or overheated rooms, that's going to exacerbate the stress and make it more difficult from a mental health standpoint. So I think there's various pathways that we can talk about, but we have overcrowding within. We see a lot of overcrowding within children's sleep spaces, with multiple individuals sharing a sleep space, sometimes a mattress, and you're focusing on enhancing sleep quality with what families have, with heaters that don't turn off and windows that don't open. It becomes very challenging, and so we have strategies that can be tailored, and I think tailoring is key to the individual family. So finding out, again, what their individual susceptibility is and what are the family's resources so that you could modify, best practices from an environmental health standpoint.
And I don't see Dr. Stroud or Dr. Trika here, but that could be a stress resilience COBRA question for a pilot project. Go ahead, Neil.
So are there technological infrastructure questions that we could drive with some of this? So one of the things that comes to mind, my wife will attest to this, that I am obsessed with indoor air purifiers, right? Because the indoor air quality is horrid, even here, right? And so, but even at a higher level, you think about air conditioning, right? So if you go into the South, they actually have pretty good air conditioning infrastructure. But I was just at a conference out in Utah where they have almost no air conditioning infrastructure. The hotels have air conditioners, but they couldn't keep up with the heat that we're starting to see come through the deserts there. Similarly here, I mean, in southern New England, we have air conditioners, but it's actually really difficult to purchase an air conditioner that is of, say, southern US grade up here in the north. And, I had this conversation with our HVAC person, like, look, climate change is real. I want to buy the one from the South. And they're like, that's not allowed. And so are there policy implications for us to think about? Climate change is real, it's happening. But for us to survive as a species, as a society, there are key infrastructural policy things that need to be looked at. And are there some data that we could start to drive some of the policy things at a local level, but definitely at a federal level?
Yeah, so I think we're going to be somewhat reliant on technology, not exclusively, where we need to use sort of all the tools that we have. I think there are real opportunities to marry mitigation, right? Reducing our how much greenhouse gases we're emitting with adaptation, where we're making changes that are protective to improve human health and reduce suffering. And so, I thought that the example of electric school buses this morning is a powerful one, right? You don't want kids sitting near a diesel engine that's idling, and those can be tools for resilience because they're very large batteries, and so sometimes they can actually support the community, et cetera. So sort of decreasing the emissions of CO2, decreasing air pollution, and so we get some health co-benefits from that mitigation. On the cooling side, you're absolutely right. We need to be planning for what's coming, not what we've had. And what we see a commitment to decarbonizing our buildings. That's going to be enormously expensive. It's a huge undertaking. In Rhode Island, our government has made a commitment that they're going to do that for all the public buildings. So when you think about, a public school that was probably built 50 years ago, right? If you're going to go in and you're going to put in, a new whole HVAC system, you're going to have a heat pump, right? So you're going to have an electrification, moving away from using fossil fuels. So we're going to, have our cleaning up of the electrical grid at the same time that we're putting in more efficient heat pumps. And then that heat pump system could be ought to be with air filtration, right? So I think it's pretty exciting and interesting that in Boston, all the public school classrooms have indoor air quality monitors. So there are thousands of indoor air quality monitors, right, measuring several of the criteria pollutants and the indoor conditions in each individual classroom, not one per school, not the principal's office, in each classroom. So it's thousands, right? And I think that kind of societal investment, right, which Rhode Island is saying it is going to do with the resources that we have, right, really does make sense. We're going to need those engineering kinds of solutions. We're going to need that technology when the sort of baseline of the environment is less healthy, right? Then you need to step in. It creates more kind of fragility to compound risks. What happens if we really need that cooling and the electrical grid goes down, right? There's more demand on the kind of engineered systems in our world. So that increases that risk of increases those compound risks, but we may need it just to keep people, healthy and safe in general. I think we really have to keep an eye on equity, because who has access to those controls, right? So we see there are really big differences in how much people use air conditioning because of their capacity to pay for it. So there's like energy justice implications. And so the penetrance of air conditioning is not necessarily a marker of the utilization of air conditioning. You can have a unit, and if it's an older, window unit, it can barely keep up anyway. It's driving up your bill. You may not turn it on until you're experiencing quite a bit more physiologic stress than if it had kicked on at a lower level. Our schools are just not equipped for that, but there's big disparities, depending on the age of the schools and, where those schools are, because different neighborhoods are different temperatures. So as we invest, things like the Inflation Reduction Act, and we're trying to decrease emissions in our society, we need to keep an eye on justice and equity so that we prioritize adaptation and improving human health in a way that decreases disparities, not increasing them.
That's great.
I have a question. Can I have a question? Yeah. So, Daphne, with recruitment and the social determinants of health, public housing, when you were recruiting, how did that work? Because I'm just thinking with public housing, it's not their control, right? It's not the tenant's control as much as when it's our own home. How did that work? Were you able to recruit those families? And the findings, I'm imagining, might have been horrific.
I mean, our referral systems are from the EHR. We look at high utilizers. We recruit from schools through our data agreements. So we haven't looked at dwelling as an identifier, but we have a high proportion of families who live in public housing. And not surprisingly, the dwelling matters in terms of, there's a higher proportion of things within the environment that they can't control. It's much easier sometimes for legal to work with a landlord, not always easy, but than some of the public housing units. And even to move out of the home environment, it takes months to years. And so even with the, physician's note. So I hope that answers your question. I think we recruit across settings in urban environments, and there's a higher proportion of public housing, and not surprisingly higher morbidity. And we see rates of asthma as high as 40% in some of the school districts that we work with. And to Alan's point, it's not just about, we can have adaptation, but we have to have sustainability with that adaptation. So even with the new school environments that we're seeing, it's great news, but they're not changing the filtration systems and the AC. And if those types of changes are not happening and constantly being monitored, that has a direct impact on air quality within the school environment.
Sharon.
Beth, I wanted to ask you, when you put on your future lens, mass migrations due to environmental change. I think that's already happening, probably. At least I speculate that. And are we going to see the return of the snowbirds to Rhode Island, for example?
Yeah, this is an excellent question. How can we predict the future, how people will move? One of the things that we've seen over the past 20 years in the United States is that migration is slowing down. There's less internal migration now than there was in the past.
Hmm.
And so when we think about a mass migration, you know, this is making a lot of headlines. I don't actually think we're going to see mass migration. I think we will see a change in the migration system that happens rather gradually, kind of hearkening back to my first comment about how I'm hopeful that extreme events are warning signals that tell people where it's safe to live or what hazards they need to prepare for where they live. And so we will build resilience into places where people already live so that they don't have to migrate. If they live in a place that has experienced repeated flood events or, you know, chronic high temperatures that are unsurvivable or you can't adapt to, those people will move. But I believe that because, you know, people are allowed to move wherever they want to move. We don't have government telling people what to do, where they can live. The housing market tells people where they can live. Mm-hmm. And so we have to pay real careful attention to where do urban planners decide to build? And are they incorporating future hazards into their design plans so that they're making places that are climate resilient in the future for people to live in and not have to migrate? Mm. I don't think of migration as being like the solution to like climate hazards or increasingly hazardous places, with the exception of some places in Florida and maybe, but I do think that we have to sort of think about this in a systemic way of how do we take the migration system that we already have where people do move and make the places that they move to, make their choices for mobility safer so that we don't have the mass migration or like the massive displacement and loss of housing that you sometimes see with an extreme weather event.
Thank you for the question. Yeah.
I wanted to ask about PFAS because I feel like it's this secret impact, not so secret anymore, but it's like this, you know, at least in my knowledge, it's still relatively limited. I'm curious if you could speak a little bit about the exposures where, I mean, we've heard about our frying pans and our Gore-Tex coats, but what populations are most at risk to PFAS exposure and where are we seeing where do we think we're seeing the ramifications in the health of people?
Okay. Thanks. Good question. So first of all, I would say that all populations are kind of at risk. And of course, we have concerns about children, infants, breastfeeding, because PFAS are present in milk. But what I would say is that the concern is that, again, I'm in a college of pharmacy, so there's a lot of drug analogies. PFAS are rapidly absorbed by the body. And not only that, but they're almost, at least the rodent studies show like 99% absorption. And then they're exceedingly slow to leave. The analogy is always like the bad house guests that you can't get to leave. So the challenge is that once you're exposed, they're going to bind to tissues like Legos. And I'll just give this analogy too. We have a couple papers out where we partnered with Pfizer and we used their drug development assays. And the student at the time, he was a full-time technician at Pfizer during the day, and then would run studies related to PFAS with those same assays in the evenings. And he said to me, Dr. Slitt, I have never I've never seen a drug that binds as tightly to human tissues as PFAS bind to human tissues. And for example, they were like 99.999% bound. They don't leave. So that's a real problem. And the problem is it's just not PFAS or PFOA or PFHXFs, which have been, withdrawn. The new emerging PFAS that are present also have this extremely high propensity to bind to, blood proteins, to tissues throughout the body, especially liver, like in general, like they get to liver. So the issue is that the replacements have just as much propensity to bioaccumulate almost as the ones that have been withdrawn. Now, coming back to your other question about pathways of exposure, what to do. Pathways of exposure, the major concern is drinking water. So we do know that in communities that are impacted with drinking water, and then there are measures put into place that serum PFAS and PFOA levels go down. So largely that's a concern. If you think about that on a United States scale, concerns are around areas where the Department of Defense has activities. There's 700 plus DoD sites that have experienced some sort or there's concerns about PFAS contamination. And a good example of that is there's a study in Anniston where the community around that Fort McClellan had about 3 times serum levels as the general population for certain PFAS. So I think those hotspots are a concern. I'm a military spouse. We lived over in Europe. So the concerns are it's just not military installations in the United States. The U.S. military is across the globe. And ironically, the water that we drank at Wiesbaden Army Air Base, those communities were all tested for certain PFAS. Ironically, they only test for 4, and there's obviously a lot more. Coming back to what we can do, I think a big part of this is understanding if there is at all or not a place for PFAS at a like high use level, or if there's obviously safe replacements, better alternatives. Obviously, there's a push which is good to maybe ban all fluorinated PFAS for certain uses. I think that's like beyond my expertise to debate. But what I can say is that what we know is that our serum PFAS and PFOA levels are lower as a general population than they were 30 years ago. And that's because there was withdrawal of PFAS by 3M, and then PFHXS by 3M, and then eventually later PFOA was withdrawn by DuPont. However, other chemicals are now going up. So when we have banked human liver tissues. We have surveyed those anecdotally from 2000 versus 2018. What we see in those livers, if you look at the pie chart of what PFAS are there, it's become a more colorful pie chart, meaning that replacement PFAS are now getting into human livers and accumulating there that were lesser prevalence in 2000. Other thing, what we see is that when you look at human serum, for example, that you just look at the concentration of PFAS that are regulated, or even, for example, the top 9, but then you start integrating advanced analytical methods that look at precursors, all of a sudden, so the National Academy of Science has this 20 nanograms per mil kind of cutoff for certain PFAS for what they consider a safe threshold of exposure. And what we see is when you start putting those advanced analytical methods in place to measure more precursor PFAS, many, many more of those same individuals would exceed that 20 nanograms per mil. So it's very complicated. And what I would just say is it seems to me like bigger efforts are what you need to lower serum PFAS levels in a population. That's not to say you shouldn't, try to use different types of cookware, or that you should, consider what types of textiles you use. But just if we think about it in a real broad, systematic way.
So we have a very wide expertise here, from macro environment to weather patterns to climate change, air quality, and chemical pollutants. But they're all exposing, it's part of our exposome, right? So what opportunities do you see of interdisciplinary research that can kind of bring together some of these seemingly different areas, but really related areas?
I want to jump in because I'm a co-director of an initiative at Brown called Equitable Climate Futures. And it's a university-wide initiative that is just ramping up right now to foster community-engaged, transdisciplinary research on climate change and whatever else you want to fill in the blank. And so, because it has to be transdisciplinary. We are holding a town meeting on November 22nd with information forthcoming about what opportunities are available through this initiative. So that is a very specific answer to your question about how to foster collaborations. One of the things that we'll have a call for proposals for working groups. And so these working groups don't have to propose to submit a grant to a federal agency. They can do that for sure. We want that. But we anticipate that a lot of teams will be at an earlier stage in the process of team development, bringing in community partners, getting a hold of the literature to really understand how the problem of climate change and fill in the blank, what are the research gaps? How can they fill those gaps in? And so believe me, the emails will be forthcoming. So keep an eye on Today at Brown. And you'll
One
hear
follow-up question on that. What about collaborations with URI faculty? Or is this just a Brown-specific initiative?
Well, there has to be somebody from Brown, and it can also include other people.
Yeah, because you're
yeah,
hospitals. As
yeah.
well. Great. So I think we'll have the Advanced CTR newsletter advertise that, I'm sure. So as soon as we find out,
And,
I know. Go ahead,
but
please.
we have to also talk about Chair C, the other opportunity at Brown.
Well, I think to your question, right, the world is complex, and increasingly our research is trying to avoid just thinking about, sort of these single causal lenses and thinking more broadly about the interactions between many different things. And I've heard a lot today about solutions, right? Evaluating what are potential interventions that could help address, mitigate, or otherwise help. So there's a lot of complexity. There's a lot of potential for collaboration to bring together different disciplines. So we're awarded a National Institute on Aging funded center on climate change and aging. And so there'll be seed awards available through that in this idea of bringing people together and capacity building, particularly with this lens of climate change and human health. So I think that we're going to need to bring lots of people to the table and consider different viewpoints and approaches and partnerships.
Yeah, and I want to plug in for Advanced CTR pilot project funding too. We have a request for proposals out right now. So if you have mentees or junior investigators or early stage investigators, I think the LOIs are due in a few days, but we don't require a lot from LOI. Just put your name in and then we'll have full proposals. And it's $50,000 for single PI and $100,000 for multi-PI projects. So, and certainly this is an area that we'd be really interested in. I know we're running up late on time, but maybe one question for people who are thinking about starting out in an area similar to yours. What advice can you give other investigators who want to get involved in the research similar to yours? What are the opportunities available? Maybe each one of you can just say a couple of lines about it. And we can start with you, Doctor.
I just want to focus on the importance of mentorship. And I think Advanced CTR obviously appreciates that focus, and finding a mentor who is, an expert in this area and putting together a team that is multidisciplinary, I think is a great way to start to build your research trajectory in terms of addressing, any needs that you may have.
So I think it's a wide open field, and for people interested in this, there are, as you probably know, NIH has a climate change and health strategic initiative. I think that one of the things that really makes people stand out when they are working on this field, on this topic, is having community partners. And insights and potential for collaboration and application, like turning around from research to solutions, is much greater when you have community partners who are there to help you with that. And the Swearer Center at Brown is investing in these sort of partnerships.
Also, you know, we have a community engagement and outreach course, part of Advanced CTR, which offers resources to people who want to put in pilot projects and stuff, which are free. Okay.
So I guess I think that there are incredible troves of public data that are available that are relevant. There may not be sufficient to answer your research question, but sometimes they're enough to show that there really remains a problem. And so I'm just a big fan of you know, diving into what public data are available, sometimes just to better understand the gap. But I think that you can often, you know, put together a pilot, you can often make a case with public data that shows if you do in fact need to collect more information. But, you know, our society has picked up the bill to collect a lot of information, and those data are often really quite relevant for human health.
So for the younger investigators, I would say that it's important to kind of expand your skill set, try research areas that are a little bit out of your expertise. Don't go too far, because sometimes obviously having a really good collaborator and finding that right collaborator in a certain area is so important. Someone who you can communicate with well and they kind of understand what you're asking. It's bi-directional. Sometimes it's an epidemiologist asking you as a bench scientist how you can tackle a question for them, and then us as bench scientists always aspiring to be epidemiologists and be able to translate our research. So finding good partnerships is really important. Just as a plug for the STEEP Superfund Center, if there's anyone who has cohorts or samples where you have an interest in measuring PFAS, come reach out to me. We can, you know, work together. Again, try to go after some seed funding and do some work measuring PFAS in your samples. We'd be happy to collaborate.
Awesome. All right. I thank you. Thank you very much for spending, you know, a few hours of your time with us and telling us all about your work and maybe inspiring some new investigators who want to join you. Thank you.
Thank you.
And thank you, everybody.
Thanks. Thank you for the invite.
Nice to meet you.
Nice to meet you too. Are you, what's your project?
So this concludes the program part of our day. We do have a networking opportunity in room 280, I think. So those of you who are able to stay, we have a chance to talk informally, and I just want to thank all of our panel discussants, our fabulous keynote speakers, and certainly all the wonderful staff, and finally the IDEA programs for helping us put on this really, for me, a terrific learning experience today. So thank you, and let's do some more talking.